Hack the planet! Hack the planet! Shut up again!
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat, and we're doing HackerFrogs After School today. We're doing a bunch of different topics, as we usually do, and let's talk about what we're doing today. So if you ever wonder where our schedule is for these streams, you can find it over at the HackerFrogs Reddit over here, and let's talk about what we're doing today. So we typically do 4 topics in a day, and we cover, well, each one of the topics is going to take around an hour. Sometimes they take a little bit longer. Sometimes they are not as long as an hour, but we try to fit it in there. So what are we doing today? So the first thing we're going to do is we're going to be taking a look at a game that you can find on Steam or, well, a bunch of other places. It's called Exapunks, and this game, it's basically doing a lot of assembly language programming, and we're going to be talking about how the game teaches you about assembly language in a little bit. So that's the first topic for today. The second topic for the day is the Temperance Labs over at HackMyVM.eu. So the Temperance Labs, we've been covering these over the past few weeks, and they teach you how to do, well, we're learning how to do Python programming through these labs. Of course, you could use whatever programming language you like, but we're going to be using Python. And Kylie Jenner, hello, nice to see you here. And you have a question? It's how do you find any number? How to find any number. Are you talking about phone numbers? Are you talking about, what kind of numbers are you talking about? Because, well, I want to make sure that I know what question you're asking first. Okay, so that's going to be the second topic of the day, and that's going to be Python programming. So that's going to be number 2. Number 3, we're going to be talking about stack-based buffer overflows on Linux x86. So we started this last week. Phone number. How do you find the owner of phone numbers? Well, I mean, there are a few different ways, but if you know the person's full name, you could, and you know where they live, you can probably look them up in a phone book. I think they've got digital white pages. Yeah, so find people, find phone numbers. I don't know if the white pages exist outside of North America, but you would search for something like this. Any tools? Well, I'm not, OSINT isn't exactly my specialty, but there are probably a bunch of different ways you could search to look for phone numbers for people. But I'm hoping that you're not asking me to do anything illegal, because we don't do any illegal things over here. Anyways, let's go ahead and talk a little bit more about what else we're doing today. So yeah, we're going to be doing stack-based buffer overflows in Linux with HackTheBox.com. That's going to be the 3rd hour of today's stream, and in the 4th and 5th hours, we're going to be doing looks like we don't have the right thing written down here, but we're going to be doing the little pivoting challenge from Dockerlabs. So Dockerlabs has a bunch of deployable Docker containers that you can hack against. And we're going to be doing their little pivoting challenge. We're going to be learning how to do pivoting over there. And it's something that you have to do every once in a while when you're doing these network hacking CTFs. So we're going to be talking about that when the time comes. But anyways, let's go ahead and start with the first thing we're doing for today, which is our game. So we've got a game. It's called Exapunks. And it's a game by a very well-known publisher for these kind of programming games. They're called Zachtronics. Zachtronics. And they do a bunch of games kind of like this. Mohammed Hassan says, greetings to all. Greetings, Mohammed Hassan. Nice to see you here. And let's see. So they do a bunch of different games that have to do with low-level programming. So Exapunks is one. And another famous one that they did is called Shenzhen IO and TIS 100. So Exapunks is probably, well, let's go ahead and start the game and we'll talk about it afterwards. Okay, so I've got the game over here. And first of all, I'm going to adjust the volume. And let me know when the volume is okay, because I want to make sure that the sound isn't too loud for everybody. Okay, so that might be okay. All right, so we'll start the game, and then we'll talk about the story in the game. We'll also talk about the game concepts. So let's go ahead and go back, and let me go over to the first level of the game. Okay, so the game starts off, and we meet this one person over here. There's a little cinematic cutscene. Let's go ahead and play it, and then we'll learn more about this world. Someone's at the door. I can't remember. Did I ask them to come up? Things have been hazy. Every day, more of my body is turned into junk.
Hey. Hey, can you hear me? I heard you were looking for some medicine for the phage. Looks like you definitely need it.
That's right, Nivus. Said they could find anything. Even bootleg medication.
So, I do have a source. I know where to get it. It's cheaper than the real deal, but it's still gonna be pricey.
Nivus pauses and looks me in the eye.
The going rate is 700 a dose. You need to take 1 dose every day. Yeah, that's dollars. Sorry, I don't set the prices. I'm just a courier. It's not like any of that money goes to me. Anyway, if you do get the money, give me a call.
Okay, so in this game, apparently we're sick. We are sick. We used to work as hackers, but we're sick, and we need to find a way to make some money. So the first thing that we decide to do is we decide to get a job online to earn some money, and this is what it looks like. Okay, so it says here, you'll be shown images of receipts generated in the course of normal everyday business, and you will enter them digitally for bookkeeping and reimbursement purposes. Save a busy executive a minute or two. So what we're trying to do is we're just trying to write down the items on this receipt, and we write down the price as well, and then we submit, and then we get paid. So, for example, we could type in VC Champagne, and it's 140, and there's DB Cabernet. So it seems like this person is ordering a lot of expensive wine. Okay, DP Cabernet for 90, and oysters. Oyster PL. I'm not too sure what PL stands for, but that's 35. We've got NY strips. Looks like they're eating some good steak for 70 bucks. Add truffles with expensive mushrooms. Sure, why not? Game Boy says, "Good night, good fight." Hello, nice to see you here, Game Boy. We're just playing a little game. It's called Exapunks, and we're trying to figure out how to afford money to pay for our medication. So let's see. Add truffles. They ordered some filet mignon for 80 bucks. and CHC Tort. So Tort, I think that's a type of cake. And special order, which they ordered for $200. Okay, so I just need to make sure that everything is correct. There are no spelling mistakes. And then we will submit this. Oh, I got 10 cents. Awesome.
Wow, a whole 10 cents. Congratulations. You only need to do 6,999 more of these, and you'll have enough for today.
So apparently in this game, I have to pay $700 a day for some sort of medication that keeps me alive. And I'm trying to find some way to make some money. Who is this?
Don't worry about that right now. You need that medication to stay alive, right? Well, guess what? I can get it to you. You'll need to start hacking again, though.
Oh no.
One hack, one dose. Easy. Deal?
I've forgotten now.
You're about to remember. Knock knock.
Okay, and then afterwards we meet this AI over here, and I think what we need to do is we need to meet with somebody. Basically, I can't. I have to play all these cutscenes for you because apparently I only have one save, unfortunately. But let's see what happens next. Someone's at the door again. An old friend. Gast. I knew his real name once, but that's gone now.
Hey, came by to give you something.
Gast hands me a small booklet. It's made of real paper. Apparently it's something called Trash World News. Gameboy says, nice games, where did you get them? I think I got this one from Steam.
I can't hack like I used to. Whatever edge I had, it's gone now. But I had to keep doing something. Something to keep the culture alive, you know? Computers are running everything these days. Before long, human beings aren't even gonna have a say. So now I equip people with knowledge. The knowledge to make a computer do what you want on your terms. Anyway, I won't keep you. I know you like to be alone. Hope you like what you see in the zine.
Okay, and we've got our magazine over here. So the game uses printed zines for technical reference. So apparently what the developer wanted you to do in this game is to print out the actual manual and to reference the manual every time you got stuck. Because there's a lot of programming that's done in this game, and yeah. Nick CCS, how's it going? Nice to see you here, Nick CCS. Let's give you a fun redeem. Let's give you a Hack the Planet, because that's what we do around here.
Hack the planet! Hack the planet! Shut up again!
But yeah, you can download the digital PDF version of this magazine, or you could print one out. And well, okay. So this is how we're introduced to it. So if anybody's interested in looking at this yourself, let me go ahead and get the digital version of that for you. So over here in this Steam thread, there's there are the pages of the actual magazine that they're referencing in here. So it's called Trash World News. It's basically, it teaches you how to play the game, and we'll talk more about this in a bit. But anyways, back to the game. Okay, so what are we doing from here? So after we meet with a friend and get our magazine, we're supposed to learn how to play the game. So the first level over here is the tutorial. So what we're going to do is, first we're going to take a look at the intro to the mission, and it's this. Would you look at that? That zine's got a hacking tutorial in it. How about that? Funny coincidence, funny coincidence, huh? Isn't it? Nice work. Thanks. This is just a taste of my power. So I guess we're talking with this I don't know if it's supposed to be an AI or not, but it's called Ember. Let's continue. Okay, so this is the first level of the game, and we just need to connect to the network. Yeah, connect to the network. And this is the main interface of the game right here. Zoomfar. Zoomfar is now a HackerFrog. Thank you very much for following on Twitch. Alright, so what do we do inside this game? So we've got these little robots. They're called Exas. And what does it say inside of the mission text? It says this move file 200 to the outbox. So we've got a bunch of different little rooms here. They're called, I think they're called nodes, but I'm not sure. But we've got little files here. We have to move our little robot from one room to another, and then we need to move to the outbox and drop the file over there. And we've got a bunch of instructions over here that do that. So the instructions here, they're all very similar to assembly language instructions in their syntax, but it's a bit hard for you all to see what's going on the screen. But unfortunately, I don't think I can make the UI elements any bigger. But you know what? I'll see if I can go to the settings and make the stuff bigger. Okay, let's go to the options. Let's go to the interface. Can I make the stuff bigger? I don't think I can. We got our display mode, we got our... Maybe if I make it lower res. If I make the game lower res, maybe the stuff will appear bigger. I don't know. But anyways, if you're having a really bad time seeing what's on the screen, let me know, and maybe I can help. Maybe I can help out. Okay, let's go back. So in the game, this is the first level here. And so basically we need to use some commands to move our little guy around over here. So we can use the link command, so link, and then we need to specify where we want to appear. So we want to appear in the 800 node over here. So this is this one over here. In each one of these levels, we can also play the level step by step. And we go over to this room over here called 800. So we start in a room called 800. We end up in a room called 800. The next thing we need to do is we need to pick up the file over here. So the file over here is called 200. So we'll go back to the beginning here. So link 800. The next thing we're going to do is we're going to grab. So the grab command is going to pick up a file that's located in the same node as us. So if we're going to grab 200, which is the name of the file here. So we can do that. Let's see, step in, do link 800 to move over, and then we do grab 200 to grab the file. So now we're holding the file and we can move over to the next room. So the next room is labeled -1, so we can link and then move over there. So the next step is link -1. So we step through. Okay, move into the room to 800, grab file 200. That was unexpected. I thought I was going to move over to this room. Hold on. So maybe I need to move to room 800 again. Okay, so let's try that again. So we move into this room, we grab the file, 200. We move to 800, which is this room. I'm not really sure why this room is called 800. I guess the node over here indicates that from here, this is referenced as 100, and 800 moves over to the other room. Oh, okay. Yeah, okay, that kind of makes sense. Great. Okay, so the last thing we need to do is we need to drop the file. So I think the command to drop the file is just called drop, but let's see what happens. Okay, so we pick up the file 200, we move over to the other room, and then we drop. Okay, so the last thing we need to do in this tutorial level here is we need to halt our program. The Tasteful Thickness says, is this the CNN headquarters? The game reminds me of Human Resource Machine. It's kind of similar. C8 capable. I'm not too sure how to I'm not sure how to pronounce your name. Let me know how to pronounce your name, and I'll try to pronounce it correctly. Thank you. But it is kind of similar to Human Resource Machine. You're using very simple instructions to navigate your character. So the characters are little robots over here. So the last instruction we need to give is the halt instruction. The halt instruction is going to tell the program that it doesn't need to do anything anymore. So okay, let's go ahead and run this step by step. So we move into I guess the direction is 800 from where we are, so it's all kind of relativistic. And then we pick up the file 200, and then after that we move in the 800 direction again, and then we drop the file, and then we halt and terminate our machine. Okay, test run complete, so we can go ahead and keep on test running this with this button over here to fast forward. We run it 100 times, and it looks like we successfully did this thing. Okay, we're going to continue editing, so I just want to understand a little bit more about how this guy moves around. So if we do link 800, we move to the next room. And then from here, to move backwards, we would move -1. So if we go back, we would link -1, and link is the movement command inside the game. Okay, so we move link 800 and then -1, so we move back and forth. So we could do 800, 800 to move into the final room here. And let's try that. So link 800, link 800, and that moves over 2, and then if we wanted to move back, we would do link -1 and then link -1 again. So let's try that. Okay, and we'll run that. Move forward 2 rooms and then move back 2 rooms. Okay, so whatever room you're in, that determines which number you use to move to another room. Interesting. Okay, let's go ahead and finish the level. So, so to finish the level, we need to link 800, and then we need to grab 200. Is this game called Exapunks? Yeah, this game is called Exapunks. So we grab 200, then we link 800, we drop the file, and then we halt. So let's run that. Okay. So that's the that is that level. Let's go back, and then let's play the outro for this mission. I can see everything, you know. Everything on your computer. Who are you? I'm allowed to have a secret or two. Besides, where are yours? I expected you to be sitting on all kinds of secrets. It's alright, though. We'll find plenty more. Okay, so let's move on to the next level of the game. I guess we've got some sort of chat going on here as well, but it's kind of hard to... If it's kind of hard for me to read, it's going to be very, very hard for you to read, because... Anyways, let's move on to the next level. So the next level is tutorial level 2. And let's go ahead... What are we supposed to do here? So tutorial level 2, learn how to edit files and manipulate values. And let's play the intro for the level. People or animals are often motivated by the anticipation of a reward. Are you anticipating the medication as a reward? I'm not like everyone else. Oh, really? Interesting. I'll have to watch for evidence of this. Processing. Okay, let's continue. Okay, so the next level is this one over here. And what do we need to do in this level? Okay, so let me read the goals for this level. So add the first values, add the first two values of the file 200, multiply the result by the third value, then subtract the fourth value. Append the result to the end of the file and then move it to the outbox. You can press the Show Goal button or F1 at any time to see a preview of a completed task. For help completing this task, see Gast walks you through it in the first issue of the zine. So the solution for this level is actually going to be in the magazine. So the magazine is over here, and for anybody who wants to take a look at what we're doing here, it's this link right here. So it's going to be the first two. Yeah, okay, so this is going to be page 8 and page 9. It's labeled Gas Walked You Through It. It basically tells you about how to complete these tutorial levels. So if we take a look at this in here, it tells you about all the different commands that we're doing over here. So it tells you how to complete the first level. These are the instructions over here. So link, grab, drop, halt. These are some of the basic instructions. And tutorial number 2 is going to be reading and writing files. So this next task is a lot like the first one, except you need to read and write the file instead of just moving it. So read the requirements in Exodus for the full explanation, okay? So to read or write a file held by an exa, you need to use the F register. So this is where we start being introduced to registers. And registers are basically little storage locations where we can put numbers and numbers and letters inside of assembly language. Okay, so we've got we move around, and then we copy read from F, so the file, and then write it to the value to X. So it's going to be copy F X. Then we do the addy command. So copy, addy, these are all different commands that we can run with the little robot. Okay, so addy xf x. I think we can zoom in super close here, and I'll do this to illustrate what's going on inside the program. So, like assembly language instructions, you've got the instruction, you've got the thing that is going to be affected, and then, well, the syntax is a little bit different in this case. So copy from the F register, and then write the value to X. This is this command right here. So add. So this is copy, this is add, this is multiply, this is subtract, and we need to learn how to use these instructions. So addy fxx, xfx. So add the value of x to the value of f, and then write the result to the X register. And this is multiply. So multiply X by F, so whatever's in the X register by the F register, and then write that to the X register. And then subtract X minus F, and then write it to the X register. And then we've got copy, let's see. Copy whatever's in the X register to the F register. And then, yeah, link 800. So basically move to the 800 node, drop the file, and then terminate the program. Okay, let's go ahead and do that. So over here, I wish I could I wish I could zoom in on this. Unfortunately, there's not very much I can do to this stuff over here. Anyways, so we got the instructions over here. The first thing we do is we move to the next node. From here, we grab the file, and then after that, we copy whatever's in the file. So what's in the file right now is the F register. So the F register is going to be, it's currently 72. We're going to copy it to the X register, which is currently 0. So 72 is copied to the X register. Next, we add whatever is in the X register to the F register. So 72 is going to be added to 52, and it's going to be saved to the X register. Silas Roger, hello. Silas Roger says, guess what? I don't know. Tell me what I'm supposed to be guessing. So okay, I learned some basics of SQL injection. Okay, that's great. Where did you learn it from? Did you learn it from Portswigger? From Portswigger Academy? I think I gave you the link to that website last time. But yeah, it's got some really good stuff. Okay. Oh, YouTube as well. Yeah. There's lots of good. Well, I mean, you have to learn from a bunch of different sources. You can't just rely on one. Okay, so we've got 52 in the file register. We're going to be adding it to X, which is 72. So this should result in 124. So X should be 124 after this step. Okay, so 124 now. Now we do the multiply. So we may do multiply X with F. So 4. So right now F is 4. We're going to multiply it by 124. So that's going to be 16. It's going to be some number. Anyways, let's find out what the number is. So the number is 496. Okay, the next thing we're going to do is subtraction. So we're going to subtract 60 from, so F is 60. It's going to subtract from 496, and that's going to be 436. Okay? So that's 436, great. Now we copy X to F. So X is 436, we're going to copy that to F. Okay, and then we move to the last room over here, which is the outbox. And then we drop the file, and then we stop the program. Okay, so that worked. Let's go ahead and complete the test runs. We need to do 100 of these. Okay, let's move on to the next step. Okay, well, let's play the outro for the mission. Does it upset you that I will provide your medications only if you work for me? So, it looks like the AI is paying us. That's kind of weird. No, nothing is free. Right. It's an exchange of goods or services. Interesting. This is good data. Okay, we're going to move on to the third level of the game. And in the third level, we're going to be doing some communication. So in the third level, learn to communicate between X's. So we'll start the level. And in this level, we're gonna create more than one of these little bots. So the bots are called X's. This one is called XA, and this one is called XB. They both start over here. And what we want to do is we want to have them communicate with each other. Okay, so let's go over to the PDF file over here. I think we don't need to look at this page anymore. We'll look at the next page. Okay, so this is the next page. So this is tutorial number 3. So tutorial number 3 is communication between X's. This next tutorial involves a file that can only be accessed through a one-way link. The exit that goes to grab the file will be trapped. So you need to create two X's and have them communicate with each other. I'll let you figure out the code for this one on your own, but here are some hints. You can now create a new file with the make instruction. The file it creates will be empty by default, and it will be automatically held by the exa that created it. An exa can delete the file it's holding with the wipe instruction. Two exas can communicate with each other using the M register. If one exa writes a value to the M register and another exa reads the M register, the value gets transmitted from the writer to the reader. If an exa is reading the M register while no one is writing to it, or vice versa, it'll wait until another exa picks up the other end of the communication. You don't need to time it perfectly. There's a toggle switch in the Exodus user interface that lets you set the M register to global or local operation. In global mode, two X's can communicate anywhere in the network as long as there's a path of links connecting them. In local mode, two X's can only communicate if they're in the same host. Finally, an exa in global mode can't communicate with an exa in local mode, even if they're in the same host. So there's a lot of different rules that are at play here. Okay, let's go ahead and go back to the game. Alright, so what's going on in this level? So file 199, which is this one over here, it contains exactly two values, a keyword and a number. Create a new file in the outbox and copy those two values to it, swapping their order so that the number is first. When you're finished, delete file 199. So, for help completing this task, see the tutorial in the first issue of the zine. Okay, so we've got three objectives here. So create the specified file in the outbox, delete file 199, leave no trace. We're going to create, well, let me demonstrate what it looks like to create a new machine. So to create a new machine, we've got this button over here, create new exa, and this exa is called XB. So the first thing we want to do, well, let's do this from scratch. Okay. So we got XA and we got XB. The first thing we need to do is we need to move them over to this node. So we're going to do link 800 for both of these machines. So the great thing about this game is that you can copy paste your instructions so you can make your workflow a little bit faster. So if we step through this, both of the machines are going to move into the room. So that's good. So the next thing we need to do is XA needs to move into this other room called, well, move into the other room with the 799 direction. So XA will link 799, and XB in the same room is going to make a file because it has to do some, it has to copy some stuff to a file later. So let's go ahead and give these instructions and see if it works. Okay, so they'll move into here, and yeah, okay. So XA is going to move into this room, XB is going to make a file, and what's going to be what's next? So XA in this room needs to pick up the file 199. So that would be grab 199, and XB is going to, I think we need to copy something, they need to copy something to the file. But hold on. Victor asks, what game is this? So this is the Exapunks game. It's a game about low-level programming, and it's basically assembly programming. So let me get the link over here. Yeah, this is Exapunks. So you can read about it over here. I'm pretty sure this is on sale right now if you wanted to buy it. Let's see, Exapunks. Yeah, right now it's 50% off. So people, well, the people that really like it, but the people who like it really like it. But right now it's $13 Canadian. I don't know what that is in your currency, but it's 50% off. Okay, let's go back to the game. All right, so let's see. XA is going to move into this room here, and it's going to grab file 199. I think XA needs to copy from the file and put it into the M register. So copy from the file, put it in the M register. Oh, it's only, Melody Miller says it's only $10, only $10 Canadian. Sorry, $10 American. Melody Miller, happy 4th of July to you. Happy 4th of July. Okay, so make the file. We need to reverse the order though. So the first thing in the file is going to be echo and then the number. But the file that we need to output, it has to be the number first. So copy M to X. We'll copy M to X, and then we'll copy M to the file. Okay, let's copy F to M. Let's see what happens here. Okay, we'll run the file. We'll run the program. These two move. Then this one moves to the other room. Oh wait. Okay, then it grabs the file, and then it copies whatever's in the file. It's going to copy to the M register. So it copies echo, and then B over here, it's going to copy the M register to the X register. Okay, and then we're going to copy the number to the M register. Okay, and then we're going to copy here, XB is going to copy the number to the file that it's holding right now. Okay, good. This is working. So the last things we need to do is XA needs to wipe the file, and XB needs to copy X to the file, because X is going to have the first the string that we need to copy to the file as well. So we're going to wipe here, and so XA is going to wipe out the file, and then it's going to delete itself by halting. But XB has got some extra stuff that it needs to do. It needs to move over to the outbox, which is link 800. And then it needs to drop the file, and it needs to halt the program. So let's see if this works. Okay, so we'll do this step by step. So XA and XB move over to the middle node here. And then XA is going to move into this room to pick up the file. And then it's going to start copying some information. It's going to copy the string, and it's going to put it in the M register. So XB is going to copy the stuff in the M register, and it's going to save it to the X register. Okay, and then XA is going to copy the number and put it in the M register. and XB is going to copy whatever's in the M register to the file, because we need to make sure that the number comes first in the file. Okay, and the last thing that XA is going to do is it's going to delete the file, and then XB is going to copy the number to the file over here, and then it needs to move over to the outbox. So XB is in the outbox, it just needs to drop the file and then delete itself. So it drops the file, it deletes itself, and that's all good. Okay, great. Let's go ahead and repeat that 100 times. Okay, done. Great. Let's move back to the level and we'll play the outro for that level. So how do you feel about it now? You're closer to the goal. Any change? What do you really want? Just curious. That's all. Anyways, there's just one more tutorial to go. You're almost there. Okay, so I think I haven't done this level yet, so this is going to be a lot of fun. And by fun, I mean kind of frustrating. We'll see what it's like. Okay, let's go ahead and play the intro. Yes, you can do it. This is positive encouragement. It's designed to increase activity in your prefrontal cortex. I'm sure it is. It better be if I can see the effect directly, but I will estimate for now. I'm sure it will help. Okay, so let's play the level. We'll connect to the network. And, well, let's go ahead and get rid of the instructions that are already here. I do know that we will need to use 2 X's for this level. Okay, so it says here, what do we need to do for this level? So file 200 contains exactly one number n. Create a new file. Victor has just subscribed. Thank you very much for subscribing on YouTube, Victor. Let's give you a Nyan Cat. Welcome to the HackerFrogs. Okay, so what are we doing in this level? File 200 contains exactly one number n. Create a new file in the outbox containing the numbers n through 0 in decreasing order. When you're finished, delete file 200. For help completing this task, see Gast walks you through it in the first issue of the zine. Okay, so let's go ahead and go over to the magazine. We'll talk about what we need to do in this level. So we're looking at this page in the magazine, and if you want to take a look at this yourself, here's a link. Okay, so this is where we do loops and conditionals. So this is real assembly language stuff here. Your final task is to create a file that contains a sequence of numbers. To do this, you're going to want to use something called a loop, which is where you repeatedly run a few lines of code until a stopping condition is met. Here are some hints. You can compare registers and or values with the test instruction. Like testing if x equals 38, test x equals 38. If the test is true, the T register is set to 1. If the test is false, the T register is set to 0. On their own, test instructions aren't that useful. But if you combine them with a conditional jump instruction, so for example tjump, which jumps if true, and fjump, which jumps if false, you can jump to different parts of the program, depending on the results of the test. So tjump, jump if true, works if the T register is set to 1. Fjump, jump if false, works if the T register is set to 0. See the connection? You'll need to specify the jump target with a mark instruction somewhere else in the program. So here's an example of a loop. Say you wanted to write the value 9999 to a file 10 times. You could do it like this, which keeps track of the number of times it's gone through the loop in the X register. Okay, so the first thing we do is copy 0 to the X register. Oh, okay, so reset the okay, so this is called zeroing out, and it's something that happens in assembly instructions all the time. Okay, so we mark the loop, we create a little label so that we can jump to this specific label later on. So define a label called loop with the mark command. Copy 9999F. So write 9999 to the held file. So the F register is the file that you're holding currently. So add to the X register 1, and then write to that register. So increment X by 1. Oh, okay, so the X register is going to keep track of how many times we've done the operation. Okay? And then test X equals 10. So test of X equals 10, and then store the result in T. So whenever we do the test instruction, the result is going to be saved in the T register. And then we do a false jump loop. So if the T register is 0, then the jump is going to have if the T register is 0, then the instruction is going to jump over to the loop label over here. So it's just going to jump from here to here. LA just says, just stop learning, you're too old. I don't think so. Anyways, you're never too old to learn. If you're an ageist and you think that people should stop learning once they get to a certain age, you're incorrect. Okay, let's keep on going. So that's the loop. So when the T jump and F jump instructions look at the value in T, they don't care if that value was put there by the test instruction or if you put the value there yourself. You can actually store whatever data you want in the T register as long as you're okay with it being wiped the next time you execute a test instruction. Okay, so let's go ahead and write our program. I think this is probably going to be the last level we do today because we've been at this for a while. Cyber Noipi says, I can't believe you're streaming on 4th of July. I guess the barbecue is over. I live in Canada, and we don't do 4th of July here. We do 1st of July. It's a different place. But Cyber Noipi, nice to see you here. Yeah, we're up in Canada. Okay, so what do we do here? So we need to create the specified file in the outbox. We need to delete the file 200. We need to leave no trace. So XA, the first thing we need to do is we need to move both of these robots into the middle node over here. So that's just going to be link 800, and the other one is going to be link 800 as well. And then XA needs to pick up file 200. So grab 200, and XB needs to make a file. So just the make command, just like this. So these commands over here, they're going to move our X's into this room. One X is going to pick up the 200 file, and the other one is going to make a new file. Okay, so now we're out of instructions, but the two X's did what they were supposed to do, which is good. Okay, so let's see. I think from here, XA needs to copy the stuff from the file over to the M register. So XA will do copy copy from the file, and we'll save it in the X register. Actually, no, we'll save it in the M register. And then XB is going to copy whatever's in the M register to the file. So let's see. The numbers n through 0 in decreasing order. I think this is going to work. Okay, let's go ahead and do that. So we create the file, we pick up the file, and what's in the file? So the file only has the number 9. Okay, so the next thing that's going to happen is that whatever's in the file is going to be saved to the M register. So 9 is saved to the M register, and then XB can access the M register and then copy it to the file. Okay, that's good. The next thing we need to do is we need to XA needs to subtract. So subtract what is in the X register by 1, and then save it in the M register. Actually, I think the loop, this is where the loop happens, right? Okay, so I'll go ahead and mark this as a loop. And I guess this is also going to be a loop. So mark this as a loop. Okay, let's subtract from the X register 1 and then save it to the M register. Asir Sharif, hello, nice to see you here. Welcome to the chat. What's up? Okay, Cybernoipy says, say I have a stable financial means to pay my daily bills. Do you think I should go and pursue full-time bug bounty, or do you think I should start a corporate job as an ethical hacker or a pen tester? Just want to know your opinion. Asir says, all great. All great, remember me? Can you refresh my memory? Because I see a lot of people every day on the live stream. Chloe Anderson says, what's up, Froggy Frogs? So we're just playing a little game over here. It does assembly instructions for programming little robots that move around and do stuff. I'm just trying to figure out how to do programming loops inside of this game. But Cybernoipy, I don't think you should start by doing bug bounties, because bug bounties, they're not stable income. I definitely think you should aim for a job that gives you a monthly salary. That's probably the better way to do it. If you want to do it as an ethical hacker or a pen tester, that's great. And right now, the best specialties inside of pen testing are cloud pen testing and web app pen testing. That's my recommendation. Asura says, I was here last stream. Yeah. I recognize your name, but I don't remember too many details. Can you remind me what your situation is? Okay, we got ads running on Twitch, so we'll run them on YouTube. And we might as well put on some birds. Okay. So we'll be back in about 40 seconds. But enjoy the birds, and I'm just going to take a little water break right now. Esther says, You have a question. Is C++ or Python greater in hacking? It really depends on what you want to do. All these programming languages, they all have different strengths and weaknesses. C++ is probably better for writing kernel hacks. If you want to write kernel hacks, if you want to write stuff that runs on Linux specifically, then probably C++. But Python is very, very popular. Python is a more general use language, and I would say you would probably want to learn Python first. It's the easier language to learn, and then move on to C++ later. But everybody's got their own perspective on this. If you've got like a use case, what do you want to do with this programming, or what kind of hacking do you want to do with the programming language? Let me know, and maybe I can give you a better answer. Okay, so let's see. So we got our loop. We're going to subtract 1 from x, and then we're going to send it to the m variable. Then we're going to test. We're going to test if x equals 0, because that's going to be the end of the loop. And if it's true, or if it's true, we're going to do a f jump back up to the loop up here. Okay? And I think the same sort of loop is going to happen down here. So actually, the same sort of loop isn't going to happen over here. Actually, no, never mind. It is going to happen. Test if m is equal to 0. Esther says, I don't know, but like hacking devices or servers, you know, I would say start with Python. Python's probably the safer programming language to learn. And from there, you can. I mean, the great thing about Python is it's got a lot of different applications, and you can always move from Python to another language. And the knowledge that you learned inside of Python is going to help you learn other programming languages, because the programming languages have a lot in common. After you learn one, it should make learning the second language easier. Okay, test if m is 0, and if m is not 0, then jump back up to the loop. Okay, so I think let's test to see if this goes off okay. All right, so let's start stepping through. What are we doing now? We're copying whatever's in the file to m. M is global. Oh, you know what? We need to set x first. So x needs to be set to 9. Okay, so we need to set x first. Hold on, we need to go back. So set we'll also copy f to x. Sox Viper says, Froggy, hello, Sox Viper. First time chatter, hello, nice to see you here. Let's give you a fun video reading. How about a Hack the Planet?
Hack the planet! Hack the planet! Shut up again!
Okay, so I think this should work. Let's go ahead and step through. So we move our bots over here, and then we pick up the file. We make a new file. Inside of the file that we're holding, XA is holding, there's the value of number 9. Okay, so 9 is going to be copied over to the global, and then the other bot is going to write the value 9 over to here. Okay, that's good. Cannot read past the end of the file. Oh, hold on. Okay, so, So copy F to M, can't read past the end of the file. Huh. I guess we'll copy M to X now. Okay. Okay, let's do this again. Okay, global 9, great, and then we copy M to X. No. Oh, okay. Hold on. Okay, we'll copy from the file to X, and then we'll copy X to M. Okay, and then we will do, and then everything will go as normal. Okay, then we subtract 1 from X and then put it in M. Oh, but we need to subtract from X as well. Hold on. Okay. Okay, so subtract from X 1 and save it to X. Man, this is getting kind of long. All right, let's do this again. So subtract. So we got 9. We write 9. Oh, this is no good. Why does this keep on? There's something wrong with the code. Okay, so subtract 1 from X and save it to M. Subtract 1 from X and then save it to X. Subtract 1 from X. Maybe we could do copy. Copy M to X, and then copy M to X, and then copy X to M. Why is it so convoluted? Okay, let's see if this works. Huh, that doesn't go. All right. Well, I think we might stop here because I need to figure out what the heck is going on. But this is a new assembly language. I need to get used to it. But you know what? We'll probably pick this back up next week, and we'll see if we can complete some more levels in this game. But yeah, if you wanted to take a look at this game yourself, then well, it's 50% off right now for the summer sale. Here you go. So we're gonna be doing some more programming stuff now, and we're gonna be doing it with Python. But in the meantime, let's go ahead and play some music. All right, so what are we doing over here? CyberNoipy says, how long have you been in the industry? So I've been in the industry for something like 3.5 years. I spent the first 1.5 years just doing training, and then I got my first job. And I guess I spent a lot of time trying to develop educational materials for people trying to get into cybersecurity as well. I figured I liked doing education stuff more than I liked doing testing, because testing is very stressful. Well, I mean, I guess teaching people is also kind of stressful at times too. But yeah, the answer is 3.5 years. Okay, so what are we doing next? So we're doing the Temperance Labs from HackMyVM.eu, and you can find them over here. So this is a series of programming challenges that we've been solving using Python. So let me go ahead and get our walkthroughs for this. So I highly encourage you to try this out yourself. Let's see, where are we? HackMyVM Temperance. So the last level we completed was level number... Oh, it should have been level number 15. Wait, did we complete level number 15? I could have sworn we did. Hold on. Okay, level 15, yeah, we completed it already. Oh man. That's okay. We'll start with level 16. But we'll use some other code that we wrote earlier to do level number 16. So the thing about code is that we like to recycle code whenever we can, because nobody likes having to write their code from scratch. Okay, let's set up our environment. And for this environment, when we're doing our coding, this is what we're going to do. We're going to have one window for editing our code, and we're going to have another window for executing the code. Okay, and let me just go ahead and make everything nice and formatted. Alright, so this is going to be where we edit the code, and I'm just going to create a little file. We're going to call it level x16.py. We're going to paste in the code that we used previously, and we'll talk about what's going on in the code as we go. This terminal here is just going to be for writing for executing the code. So CyberNoipy says it means I'm not really late if you're this good in 3.5 years. Yeah, you know, it's never too late. Somebody came into chat earlier and they said you're old, you shouldn't be trying to learn. I think the person said that they were like some sort of 20-year-old hacker who earned, I don't know, like tons of money by doing credit card fraud or something. We don't encourage people to commit crimes here. If you're a hacker who commits crimes, you're not welcome here. We're here to teach people how to do cybersecurity and to be good people. Anyways, let's keep on going. Okay, so before we start this next level, actually, maybe I should do my introduction first, because eventually I need to turn all these into YouTube videos. Okay, everybody, this is a guided walkthrough for level number 16 from the Temperance Labs over at HackMyVM.eu, and let's take a look at what we need to do for this level. So, in this level, in this mission, you need to receive a PNG encoded in base64, you must decode it and return the size of the pixels of its width and height. So this is going to be kind of complicated. First thing we're going to do, well, it says in the example here that we're going to receive base64 encoded PNG files. What we need to do is we need to convert the base64 file, or the base64 input, into back into its original form, which is a PNG file. And then after that's done, we need to send back its width and height of pixels, and that's what we're going to send back. So how are we going to do this? Let's talk about it. So first of all, over here, let's talk about what the script does. Well, what the basic script does before we start modifying it. So the first thing we do is we import the socket module. So the socket module is a library in Python which enables communication with the remote server on an arbitrary port. So to use this, we need to specify a host, which is this server right here, temperance.hackmyvm.eu, and we need to specify the port that we're going to communicate on, which is 9988. The first thing we do in the script is we create a socket object, and the object is what we're going to be using to send and receive data from the server. So with socket.socket, socket.afnet, socket.sockstream as S, we're going to connect to the server. So S is the name of the socket object that we create. So when we want to connect to the server, if we want to receive information, if we want to send information, we just need to do s dot something. So it's going to be s.connect or s.receive or s.send. So the first thing we're going to do is we're going to connect to the server using s.connect. We use this host and this port, and then we're going to print out a little message receiving intro, and then we're going to receive some data from the server by receiving 1024 bytes, and then we're going to print that out. So what we're going to do to start the level is we're going to do this. We're going to receive data from the server, we're going to print it out. Then we're going to send some bytes to the server, depending on which level we want to access. In this level, we're going to access level number 16. So we need to send level 16 in bytes back to the server. The next thing we're going to do is we're going to receive something from the server, and then we're going to print that data out. So we're just going to workshop this code to make sure that everything is working up until here. We comment out everything that's underneath here from the previous script. David G says hello. Hello, David G. Nice to see you here. Welcome to the stream. Let's give you a Hack the Planet.
Hack the planet! Hack the planet!
We're just writing some Python over here to do some hacking challenges. Okay, so we're going to save out the script, what we have so far, and then in our other window, KissKiller0 says, hey, where is my Hack the Planet? I'm pretty sure that the Hack the Planet is on a cooldown, like a minute or two, but we're going to give you, KissKiller, let's give you a nancat. Welcome to the stream, KissKiller. Okay, so in the other terminal here, we're just going to run this file. So Python level 16.py. Okay, so we receive the introduction message from the server. Then we receive the challenge. So we're told that this base64 string here is a PNG image. So the first thing we need to do is we need to figure out how to decode this base64 information here. And well, we can probably just ask on Google or something. So let's see, in Python, how do we decode bytes? How do we decode base 64 bytes? Okay, so we asked this. Kisskiller says, even better, thank you. No problem, Kisskiller. All right, so let's see. In Python, base 64 encoded bytes are decoded using the base 64 module, specifically the base64 decode function. Okay, so import base 64, and this should be a bytes object. If you have a base 64 encoded string, you must first encode it to a string. So this is okay because we got bytes. So encoded data equals this. Decode the base 64 bytes, base64.b64 decode to perform the decoding. This function returns a bytes object. Okay. Okay, so this is going to return bytes. Let's go back to our code. So we need to import base 64. That's the module we're going to use. Okay, so we received the challenge. The next thing we need to do here is we need to convert the base 64 bytes into convert the base 64 bytes back into its original form. Okay, so how do we do that? We do this. So, So base 64, we'll just call this PNG bytes, because this is going to return some bytes. It's going to be data 2, and we do what is that called again? Base64.b64 decode. Okay. Base64.b64 decode on data 2. And then we'll print that out. So print this is the PNG decoded from base 64. And it's probably going to be a bunch of gibberish that we can't read, but that's okay. So let's see. So this is going to be PNG bytes. Okay, let's save that out. And then let's run the script again. Okay, so this is the PNG decoded from base 64. We received the base 64 encoded bytes here, and then we decode it, and these are the bytes that we receive in return. So this is a PNG file because, well, we see the PNG magic bytes up here. And what can we do from here? Let's ask Python. Sorry, let's ask Google. Okay, so in Python, how do we... So, okay, we should probably look at the goal for the level one more time. So the goal for the level is you receive a PNG encoded in base 64. You must decode it and return the size of its pixels, its size in pixels of its width and height. Okay, so how do we decode a base 64 encoded PNG and return and determine its dimensions in pixels? Okay, let's see what we get here. Get base 64 image dimension in Python. Okay, so let's take a look at the Stack Overflow. So how can 1. Extract the image dimensions from a string, preferably without storing the string to disk as an image. Okay, so we've got import IO, import PIL, from PIL import image. And we got image data equals this thing. Then we got image.open, image.open. And then im size. Huh. Okay, so we need to import some extra stuff here. Import IO, import PIL. Okay, so David G says, perhaps search for image manipulation module in Python to see if there's something. You pass the bytes to a class and get the metadata of the image. So we'll try this stuff that we found in Stack Overflow. If it works, then great. If not, then we need to do some more searching around. So import IO, import PIL, from PIL, import image. Let's give this a go. So it looks like we need to import a bunch of stuff. Okay, so what do we do from here? So we got our bytes. David G says, I think you need to install the Pillow library. I think PIL is a standard library, but I could check up here. So let's just run Python. Import PIL. Yeah, so it didn't give me an error message, so I'm pretty sure it's a standard library. Okay, so what do we do here? We're going to be opening the image. So we need to open the image, and I guess we would do open the image, then get its dimensions. Okay, so the image, we're just going to call this image equals, what is that code? Image equals image.open. I mean, maybe I shouldn't be. We'll call this PNG image just to make sure that there are no problems. So PNG image equals image.open, io.bytes, io image data. Image data. Wait. No, this isn't supposed to be image data. It's supposed to be the name of our. Yeah. It should be the PNG bytes over here. Okay. And then we need to run some ads because, well, we got ads running on Twitch right now, so we're also going to run them on YouTube. But for everybody else, you get to enjoy some birds. So this is, well, these are my favorite birds. Please enjoy the birds, having some peanuts. We'll be back in about 60 seconds. I'm just going to take a little water break. If you need to get up and stretch or use the washroom, this is a good time to do so. Okay, ads are ending in just a little bit. So Cypher asked, "What kind of bird is this?" So this is these are Stellar's jays, and they're kind of like the West Coast version of blue jays. On the East Coast, you'll find blue jays, but on the West Coast, you'll find Stellar's jays. Anyways, let's put the birds away. Let's get back to the hacking. Okay, so what are we doing here? So we're doing we'll just call this one dimensions. So the dimensions is going to be equal to whatever is over here. Width height equals IM size. IM dot size, or like the object dot size. Okay, so let's just make sure we can get these things. So dimensions equals PNG image dot size, and then we'll try printing this out. So print as an F string. These are the dimensions of the PNG image. And then we will print out the dimensions. Okay, I think let's go ahead and see if we can get this working. Okay, so yeah, it seems to be working. Great. All right, so we received the base64 encoded PNG, and this is the PNG decoded from base64. This is just a bunch of bytes, and these are the dimensions of the PNG image. We got 13 and 26. So we probably need to format this as a string first. This looks like it looks like an array. So first of all, I want to find out what type of data this is. And let's see. Print type for dimensions. So I've got a feeling that this is an array. It looks like an array, but I just want to make sure. Okay, we'll save that out. Run the thing. This is a okay. So the array is called a tuple in Python. So we just need to save these two things out to, let's see, I think it's width and then height. So the first number should be width, the second number should be height. Okay, so the next step is to save the width. Save the width and height as variables. And how do we do that? So let's see. PNG width is going to be equal to dimensions element 0. So element 0 is the first thing in the tuple, which is 97. Well, in this case it's 97. I'm pretty sure it changes every time we run the program. So PNG height is going to be dimensions element 1, and then we're going to print it out. So print the dimensions, or we'll just say the width of the image is something. The height of the image is something else. Okay. So this is dimensions, or this is PNG height, and the other one is PNG width. Okay, hopefully this works. Let's save this out. Let's run the script again. The formatting's a little bit weird. I'm gonna change it out. Okay, let's do this again. Okay, so the dimensions of the PNG image are this, the width of the image is this, the height of the image is this, and we need to get the string format that that the server is expecting. So it's expecting a specific format. It's basically expecting width x height. So width x height. Okay. Get the exact string format that the server is expecting. Okay, so this is going to be formatted string. This is going to be the string version of the formatted string is going to be the string version of PNG width plus the X character plus PNG height. Okay, and then we'll print it out. Print the correct format is this formatted string. Okay, save that out, run it again. Unsupported operand for type plus int and str. Okay, so we're going to specify that this is a string as well, and we're going to specify that this is a string. Okay, let's do that again. Okay, so the width of the image is 19, the height of the image is this, the correct format is this. Okay, that's great. So the last thing we need to do is we need to convert this string to bytes, and then we can send it back to the server. The reason we need to convert the string to bytes is because the socket object only sends bytes. It cannot send anything that is not bytes. So that's why we need to do this. Okay, let's we need to convert the string to bytes, this step over here. So bytes is going to be equal to formatted string dot encode from UTF-8 into bytes, and then we send it back, and then we receive the flag. So this is what we're hoping is going to happen. Okay, so this should be the last iteration here. Okay. Great, it worked. So what happened? So first thing we did was we received some base64 encoded bytes here, and then we converted the bytes into a PNG file. So we converted it into a PNG file with these contents, and then we used the Python image library to read in the file and then extract the dimensions, which are this. We got those dimensions, we formatted it into the correct format here, which is what the server wanted. Then we converted that into bytes, we sent it off to the server, and then we got the flag. So we just need to grab this flag and submit it to the server to finish the challenge. Okay, so submit this. And we timed out. Okay, let's go back to the challenge and try that again. Okay, this is level 16. Let's submit that flag. You have submitted this. You have submitted the flag successfully. Great, great, great. Okay, so everybody, this was a guided walkthrough for level number 16 from the Temperance CTF labs from HackMyVM.eu. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, I think we might have one more level. That we could probably finish one more level today. Let's go ahead and save this out. And let's copy this to our GitHub, because we need to make sure that we document all of our code, because if we didn't document it, then it didn't happen. And we definitely want it to happen, and we definitely want to document our stuff. Okay, so we got our code. Let's create this over on GitHub. This is level 16.py. Paste it in, okay, and then commit this. Okay, let's move on to the next level, level number 17. So we're just going to rename this. Rename level 16, we're going to call it level 17. Okay, let's take a look at what we need to do for this level. The next level, number 17. Where are we? Here. Okay, everybody, this is a guided walkthrough for level number 17 from the Temperance CTF labs from HackMyVM.eu. Let's begin the level. So what do we need to do in this level? So the mission says, in this mission, you will receive a 1-pixel PNG encoded in base64. You must decode it and return the last RGBA value. Okay, so return the last RGBA value. Okay, so we received this. We're supposed to send some sort of value. It's probably going to be a number like this. Let's figure out how to do this. Let's go back to our code. And we're mostly using the same code that we did for the previous level. We just need to change some things in the script. So the first thing we're going to do is we're going to convert the base64 strings back, and well, we're just kind of expecting that everything is going to be very similar to the previous level. Kolkus says, hello Kolkus, nice to see you here. And the one thing we need to do is we need to change the level that we're going to access when we send those bytes. So we're just going to send level 17 instead of level 16. Okay, let's go ahead and save this out. So we're just going to receive the bytes from the server, and then we're going to convert those base64 bytes into its original form and then print those out. So let's go back. And yeah, we get basically what we expect here. So we receive base64 encoded bytes, and then we transform those bytes back into a PNG. So after that, we need to answer the following question. How do we get the RGBA values? So in the code here, in the last level, we used the PIL module from Python, and we used it to get the information about the PNG. The next, well, I mean, in this level, we need to get some different information. So let's ask some questions. Using the PIL image module in Python, how do we get the last RGBA value in the image? Let's ask the question. Okay, so the AI has an answer for us. Let's take a look. To get the last RGBA value pixel in an image using the PIL image module in Python, you can follow these steps. So open the image. So image.open, ensure RGBA mode. If the image is not already in RGBA mode, convert it using image.convert RGBA. This ensures that each pixel has red, green, and blue and alpha components. Okay, so get the image. Do we need to get the image dimensions first? Access the last pixel. Really? Is this how you do it? Okay, so we've got some Python code here. Open the image. Image.open. So this is the same as the previous level, so the code we used in the previous level. Convert it to RGB mode if not already. Okay. Let's see. Get the image dimensions. Width height equals image size. And last RGBA value equals image.getPixel. GetPixel. Huh. That's funny. Width -1, height -1. Okay, let's try creating this. Okay, let's start writing this. So everything, all the code in here is going to be very similar to the previous level. So we save the height and width as variables. Actually, we don't need to do this. Open the image and then get its dimensions. So we do this, image.open. Yeah, we do this on the PNG bytes, great. Let's see. So we'll do what they say in the suggested code here. So width height equals image.size. So width height equals image.size. Okay. Width height equals PNG image.size. And then we can print out these are the dimensions of the PNG image. Sure, let's do that. And let's see if this works up until this point. We'll save the script and then we will run the script again. Okay, so the problem here is that we're using dimensions here. We don't want to use dimensions. We want to use width and height. Okay, let's see if this works now. Okay, these are the dimensions of the image. 1, 1. Oh, we were told that there was only 1 byte. Yeah, okay. There's only 1 byte, so we just need to get the the RGBA value for this single pixel here. Okay, so we need to convert it to RGBA mode. So let's go ahead and do that with this little piece of code. I guess we can do it up here in this code as well. So open the image, convert the image to RGBA. So let's see. PNG, we're just going to do the conversion in place. PNG image equals open the image, and then we convert it to RGBA there. And after that, I think we can do the next step. And the next step is going to be get the RGBA value of the last pixel. So there's only one pixel, so it should make it a little bit easier. Get the last pixel's RGBA value, so that's going to be, we'll just call this RGBA value. So width and height. So we just need to do width and height. Okay, we're going to call this RGBA underscore value. It's going to be this. Get pixel. Get pixel? Is that a... Oh, it's image.getPixel. Okay. So that's going to be... PNG image get pixel. Does this... It's just going to be width and height. Okay, so let's go ahead and print this as well. This is the RGBA value of the last pixel. And let's print that out. RGBA underscore value. Save that out and run the script again. Index, image index out of range. Image index out of range. So do we need to do, maybe we do need to do width -1 and height -1. Okay. So this is the RGBA value of the last pixel. Why? We've got too many numbers. We got 1, 2, 3, 4. Hold on. What does the server expect? You must decode it and return its last RGBA value. So I'm guessing that we only want the last number. And if that's the case, let's do another definition. So last value equals, oh, right, it's red, green, blue, and alpha. So I guess we're only looking for the alpha value in this case then, right? Last value equals RGBA value element -1. Okay, so print out, this is the last value. GX000 says this looks steganographic. Well, I mean, we're dealing with PNGs and like RGB values. It's kind of expected. Okay. Let's see if it works up to here. Okay, so the RGBA value of the last pixel is this, and the last value is this. So we just need to convert this into, this is probably an integer, and we need to send back bytes. We need to turn this into a string first. So What are we going to do here? Yeah, bite me, of course. Welcome to the stream, GX000. Nice to see you. Okay, so convert the integer to a string and then to bytes. Actually, we can do this all in one step, right? Last value string. It's just the string version of last value. Okay, this is the integer converted to string. And we'll call this last value string. Okay. This should be the last thing we do. We should be able to send this back to the server after this. Okay, this is the last integer converted to string. Great, great. Okay. Convert the string to bytes. This is just going to be last value string dot encode. So we should be able to just send this back to the server and then get the flag. So I'm just going to finalize the script, write it out, and then run the script one more time. Great, it worked. So what happened there? So we received a base64 encoded string. Base64 encoded bytes. Spy controller says, yo, we hacking the FBI? Not exactly the FBI. We're just learning some, how to use some programming tools. So when we do our hacking, we often use a lot of different tools. And we're just going to be programming some little scripts to do the work for us. Okay, so we got our base64 encoded bytes, then we converted it back into a PNG. After we convert it back into a PNG, we work with it, and we get the dimensions of the image, we get the RGBA values of the last pixel in the image, which are these. The server only wants the last value here. We convert this integer into a string and then back into bytes, so that we can send it to the server. We send it to the server, and then we get the flag. So the last thing we need to do is we need to copy this and send it back to the server to confirm that we've finished the challenge. You have submitted the flag successfully. Great! Okay, awesome. Alright everybody, this was a guided walkthrough for level number 17 from the Temperance Labs over at the HackMyVM.eu website. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video, and leave a comment underneath the video. But until next time, HackerFrogs out. Spy controller, hey, what's up? What is up? What is up? We need to play some ads on YouTube, unfortunately. But we're going to be starting the next part of today's challenge in just a little bit. Okay, we got ads running on Twitch right now, so we're going to run the ads on YouTube. We're going to put on our birds, and then we will be back in about 30 seconds. So enjoy the birds. We'll be back in a little bit. I just have to take a little water break. Okay, let's get back to the hacking. Ken BDX, welcome to the stream. Nice to see you here. And Ken BDX says, I remember those frogs. Well, I mean, I don't remember what year did they run that commercial. It was like a long time ago. Was that the 80s or the 90s? Okay, let's go ahead and we're gonna document the script that we used to solve the level, because if you didn't document it, it didn't happen. This is something we need to remember in cybersecurity, in tech in general. You want to be able to document everything that you did. Like 40 years ago or more. Well, I mean, we can look this up exactly by doing a Google search. Okay, when did the Budweiser frog commercial come out? Okay, 1995. I mean, is that 40 years ago? Hold on. So it's 2025 now. I mean, it's 30 years ago. Not exactly. It was like mid-90s. Yeah, I mean, I remember seeing it on TV. It's more recent than I thought. Sometimes that your memory deceives you a bit. But yeah, what were we doing? So we're documenting our progress over here. Okay, so let me create a file. This is level number 17. Okay, commit the changes. We're done. Great. All right, everybody, we're going to be moving on to the third piece of content for today. So in the third part of the stream, we're doing this. We're doing stack-based overflows, stack-based buffer overflows on Linux x86 part 2. This is going to be done over at HackTheBox.com. So if you want to take a look at the same module that we're looking at, that's the link right there. So the good thing about this module is that it doesn't well, I mean, it's a free module, so you can just sign up for an account over at HackTheBox.com, and then you can start doing this module right now if you really want to. But yeah, let's talk about what we need to learn to do our buffer overflow and binary hacking. So we're talking about CPU registers now. So registers are essential components of the CPU. Almost all registers offer a small amount of storage space where data can be temporarily stored. However, some of them have a particular function. So the registers will be divided into general registers, control registers, and segment registers. The most critical registers we need are the general registers. In these, there are further subdivisions into data registers, pointer registers, and index registers. So if for some reason, if you get confused while we're talking about any of the stuff here, please ask any questions you might have in the live chat. I'll try to answer the questions as best I can. I'm not an expert on CPU architecture or buffer overflows, but I'm trying to learn, and I hope that everybody can learn along with us. So the first registers we're talking about are data registers. So remember that registers are just little storage locations where you can put your data temporarily. So we've got the difference between 32-bit registers and 64-bit registers. The 32-bit registers are going to start with E, and the 64-bit registers are going to start with R. But when you think about the registers, all you need to really understand is that there's an A register, a B register, a C register, and a D register. Because registers basically stay the same. It's just that where they are, depending on whether or not they're 32-bit or 64-bit, that determines the letters that come before. So E for 32-bit and R for 64-bit. So the A register is the accumulator. And the accumulator is used in input-output and for arithmetic operations. The B register is the base register used for indexed addressing. The C register is the counter register used to rotate instructions into count loops. And the D register is the data register used for I/O and for arithmetic operations for multiply and divide involving large values. So when you do division, so part of the division result will show up in the D register. It's not really something you need to know, but it's just some fun that I wanted to point out over there. We also have our pointer registers. So we got each one of these registers are going to have different suffixes or prefixes, depending on if it's a 32-bit or a 64-bit register. So you just need to remember the end of this, which is IP. So it's IP, SP, and BP. And IP stands for instruction pointer. The instruction pointer stores the offset address of the next instruction to be executed. Silas Roger, majestic you say. I'm just trying to teach people. If you like the way I teach, then well, I'm glad. If you don't like the way I teach, then there are a lot of other places to learn stuff as well. You don't need to learn from me. Okay, so there's the IP register. The SP register is the stack pointer. The stack pointer points to the top of the stack, okay? And the BP register is the base pointer. So the base pointer is also known as the stack base pointer or the frame pointer that points to the base of the stack. We got stack frames, and since the stack starts with high addresses and grows down to lower memory addresses, the base pointer points to the beginning, which is the base of the stack in contrast to the stack pointer. So the base pointer points to the beginning of the stack. And the stack pointer points to the top of the stack. Awesome, okay. Thank you very much for... GX00, he's a hottie in a hat. Hottie in a hat. Well, only if it's hot outside. Streamlabs, thank you. Well, no, wait. Iki Sai, thank you very much for following on Twitch. Let's give you a fun video redeem. How about some desert frogs? Okay, so as the stack grows, it is logically divided into regions called stack frames, which allocate the required memory into the stack for corresponding function. A stack frame defines a frame of data with the beginning EBP and the end ESP. So the base pointer is the beginning and the end is the stack pointer. No, we don't have any of those frogs, unfortunately. CyberNoipy says, just trying to get some exposure. When you watch something at the beginning, you don't understand, but the more you watch, the more it starts making sense. Yeah, for sure. I mean, it's a pretty big topic. It's a very, very big topic. CPU architecture. You have to understand like how programs run inside of the computer memory in order to do these buffer overflow attacks. You could just do the buffer overflow attacks without understanding what's going on inside, but that is not what we want to. That's not the best way to do things. Okay, so as the stack grows, it's logically divided into regions called. Okay, so there's the beginning of the frame, which is the base pointer, the end of the frame, which is the stack pointer, that is pushed onto the stack when a function is called. Since the stack memory is built on a last in, first out data structure, so last in, the last thing that goes into the stack is the first thing that's going to leave the stack. The first step is to store the previous base pointer position on the stack, which can be restored after the function completes. So if we look at the bofunc function, it looks like the following in GDP. GNU debugger, okay? CyberNoipy says, the other day I was watching someone doing some binary hacking. I had zero clue what they were doing. The only thing I know is that it's binary and it's hacking. Yeah, for sure. It's not super easy to explain. But when we actually get to the buffer overflow stuff, I'll try to give an explanation that is a little bit easier to understand. Okay, so we got the bow function, we got the disassembly here. I think I'm going to log in to SSH on Try Hack Me, because when we answer questions, they're assuming that we're accessing their machines. So I'm just going to go down to the bottom. We've got a machine that we can start up, I'm pretty sure. Oh, okay, they don't. Okay, that's fine. What were we learning about here? Okay. So this is the stack frame right here. As soon as the function runs, it pushes whatever is in the base pointer onto the stack. So it pushes the BP, the base pointer, or the memory address onto the stack so that it can retrieve it later. And then it does its functions. Whatever it does is going to be in here. And then it's going to restore. Well, it should be doing some restoration stuff before it finishes the function. So the base pointer in the stack frame is set when a function is called and contains the base pointer of the previous stack frame. Next, the value of the ESP is copied to the stack pointer is copied to the base pointer, creating a new stack frame. Okay, so it pushes the value of the base pointer onto the stack, and then it moves the stack pointer into the base pointer to create a new stack frame. Then some space is created on the stack, moving the stack pointer to the top for the operations and variables needed and processed. Okay, so this is the prologue of the function over here. So the base pointer is going to be pushed onto the stack so that it can be restored later. Then the stack pointer is going to be moved into the base pointer. And then finally, the stack pointer is going to be subtracted and then moved to the top. So these three instructions represent the so-called prologue. Divus Mutterings Levin says, you had to start the VM on the previous task. Oh, I mean, if we need to start the VM, we'll go back to the previous task and we'll start it. But if we don't need to start up the VM right now, we won't start it. Okay, so these three instructions represent the so-called prologue. For getting out of the stack frame, the opposite is done, the epilogue. During the epilogue, the stack pointer is replaced by the current EBP, and its value is reset to the value it had before in the prologue. The epilogue is relatively short, and apart from other possibilities to perform, it's performed with two instructions. Okay, so the two instructions we need to do is we need to push the base pointer onto the stack. We need to move the stack pointer into the base pointer. And isn't this the same as the prologue? Hold on. So the prologue is here, push EBP, move ESP to EBP, push EBP, move ESP to... Okay, it looks exactly the same. Alright, so we got our index registers. So, source index and destination index. So we just need to remember that these are the SI and the DI. The source index is used as a pointer from a source for string operations. Oh, string operations. We need to keep this, we need to remember this. So destination is used as a pointer as a destination for string operations. Okay, so these are both used for string operations. Another important point concerning the representation of the assembler is the naming of the registers. This depends on the format in which the binary was compiled. We have We've used GCC to compile the bow.c code into 32-bit format. Now let's compile the same code into 64-bit format. Okay, so we're gonna have to use the... Yeah, okay. Let's go ahead and get the let's SSH into the machine, which was used in the previous task. So just a second, everybody. Okay, so click here to spawn the target system. Let's do that. So we're going to use SSH to make contact with the system. This gives me a good opportunity to close out the other window I was using over here. So the first thing we need to do first, well, the thing we need to do first, rather, is we need to make contact. We need to open up the VPN connection to HackTheBox. So we're just going to VPN into HackTheBox, and then we can SSH into the box from there. So let's see. We need to supply this username. And we need to get the server IP. Okay, let's log in. The password is right here. Okay, great. So what do we do now? Let's go back to where we were. Okay, so compile in 64-bit format. We don't have bow.c. Bow.c was probably in the previous... Okay, let's see if bow.c is here. It's not. I think we have to create it ourselves. Okay. And I'm pretty sure the code for the bow.c file is in the previous task. Let's go ahead and go get that. All right. HackTheBox is going a bit slow. Are we loading up? All right, let me go ahead and close out some of these windows that we're not using. Because if I don't do that, it's going to bother me. Okay. Let's get that code. So the vulnerable program was this. So bow.c. This is the code. Let me copy it. Then let's paste it into our code window. Save that out, and now we should be able to compile the program like they want us to. How do we go to the... Just want to go to the next page. Defus says you don't really need to do that. It'll spawn a different machine on the next task. This is really just if you want to do what they show you anyways. Let's see. Cowlmaster says I think it's already compiled under the name bow. I'm pretty sure that's the 32-bit version. Yeah, so this is the 32-bit version. I'm going to compile the 64-bit version. I just want to give this a try because it'll make the examples that they're talking about make more sense. Okay, so here, this is the command. We're going to create a file called bo64. Okay, so bo64. This is the 64-bit version of the Laps says, is the Academy free or not? This one is. So if you want to take a look at the same stuff we're looking at, this is the link. You'll need an account over at HackTheBox.com, but it is free. Okay, so let's take a look at the assembler code. We'll see that the addresses are twice as big, and we have almost half of the instructions as with a 32-bit compiled binary. What do they mean by half of the instructions? Okay, so we'll run GDP. And what was that command that I used? Disassemble main. Oh wow. This is not very many instructions. Oh, I think we need to switch the syntax, right? How do we switch the syntax to? We want to switch it to the Intel syntax, because the AT&T syntax, I don't like looking at it very much. DB switch to Intel syntax. Set disassembly flavor Intel. Okay. This is the instruction here. And then do disassemble main again. Yeah, this is what we want. This is much easier to look at. I don't like looking at the AT&T syntax. Not very fun. Okay, where were we? Okay, we'll first take a look at the 32-bit version of the vulnerable binary. The most important instruction for us right now is the call instruction. The call instruction is used to call a function and performs two operations. It pushes the return address onto the stack so that the execution of the program can be continued after the function has been successfully fulfilled its goal. It changes the instruction pointer to the call destination and starts execution there. Okay, so let's go back to the 32-bit version. So the 32-bit version is this one right here. Whoops, hold on. Black Shell, hello, nice to see you here. We're just doing some we're just learning about some binary hacking stuff. And then we do disassemble main. Wow. Why? So the instructions for the 64-bit binary, there are not very many of these instructions, but for the 32-bit binary, like, there's twice as many instructions. Is that because the memory registers are smaller? Okay. So the return address onto the stack so that the execution of the program can be continued afterwards. The call instruction. Okay. So we're looking for call here. And there's also the bow function call down here. Okay, so what are we looking at? Oh, they changed back to AT&T format. Hold on, what was that instruction again? Set disassembly flavor Intel. Binary hacking is reverse engineering, or is it different? So this is well, I mean, there's reverse engineering elements in this as well, because we're learning how to understand how the assembly instructions are running. But yeah. Drug Pearl says binary hacking is more overflow and underflow. But I mean, either way, you need to be able to read what the program is doing. But yeah, you use reverse engineering to do binary hacking. The two are kind of interconnected. You can't really expect to, well, you can do reverse engineering without doing binary hacking, but you can't do binary hacking without understanding reverse engineering. That's how it goes. Okay, so what do we got? Endianness. So during load and save operations in registers, the bytes are read in a different order. The byte order is called endianness. Endianness is distinguished between the little endian format and the big endian format. Big endian and little endian are about the order of valence. In big endian, the digits with the highest valence are initially. In little endian, the digits with the lowest valence are at the beginning. So mainframe processors use the big endian format since RISC architectures, mini computers, and in TCP IP networks, the byte order is also in big endian format. Let's take a look at these values here. So we've got an address. This is a hexadecimal address, and then we've got a word. Why did they call this one a word? But yeah, so if we've got the same word here, in big endian, we start from left to right. We read it this way. But in little endian, we read it right to left. It goes this way. So it starts at D and and ends at A. But in big endian, it starts at A, it ends with D. So can be indexed as American Indians or South Asian Indians. Are you talking about Lilliputians? And are you talking about Gulliver's Travels right now? I'm not too sure. But yeah. This doesn't have to do with people. This has to do with bytes. It's very important for us to enter our code in the right order later when we have to tell the CPU to which address it should point. So most of the time when you're dealing with x86 compiled binaries, they're going to be in little endian format. And RDT, let us know how to pronounce your name, thank you. But welcome to the HackerFrogs. Let's go ahead and give you a fun redeem. How about a Hack the Planet?
Hack the planet! Hack the planet! Shut up again!
Okay, we've got ads running on Twitch right now, so we're going to run them on YouTube. And we're going to play some birds. Here's a bird. We'll be back in about 30 seconds, just have to have a little water break. Barney, hello, nice to see you here. The bird is checking out the camera. Good to be here. So Ardit, I'm going to say Ardit. But Barney, hello, nice to see you here, Barney. I'm not too sure how to pronounce the rest of the name, but I can recognize Barney. Okay, let's go ahead and put the birds away. Let's get back to the hacking. So yeah, so most of the time we need to do little endian when we're putting our bytes into the program, and we'll just make a note of that and move on to the next section. Best bird every time. Thank you. Okay, so this is part of the this is the meat of doing our buffer overflows on x86 Linux. It's taking control of the instruction pointer. One of the most important aspects of a stack-based buffer overflow is to get the instruction pointer under control so that we can tell it to which address it should jump. This will make the instruction pointer point to the address where our shell code starts and cause the CPU to execute it. We can execute commands in GDP using Python, which serves us directly as input. Serves us directly as input. Okay, so we're gonna be running some Python to overflow the buffers inside of the program. Cobblemaster says, could you run Python inside of GDP? I don't. Wait, is that what they're doing? Huh. It looks like that's what they're doing. We should probably... Yeah, I don't use GNU Debugger very much. I usually use Radare 2, but Blackshell says, do you have to be familiar with assembly? So you do need to learn how to read some assembly to do binary hacking, because if you don't understand what the instructions are doing, you become very lost very quickly. Alien says, I'm a beginner. No worries, no worries. If you have any questions about any of the stuff we're doing, let us know and we'll try to explain as best we can. Okay, so this is the 32-bit version here, and I think we're running the 32-bit version right now. Okay, so let's go ahead and run the Python command here. So run Python, starting program. This is going to give a segmentation fault. This crashes the program. So what are we doing here? So inside the debugger, we're running a Python command to print out this thing 1200 times. So hex 55. Hex 55, I'm not sure what this is in ASCII. I should probably figure it out. So let's see. Hex 55 ASCII. Oh, it's the U character. Okay, so we do the U character 1200 times. And this is what we're feeding to the binary to crash it. Okay, so we run the thing and it gives us a segmentation fault. Segmentation faults are basically where the program tries to access an illegal memory space, and that crashes the program. Okay, let's go back. So if we insert 1200 U's hex 55 as input, we can see from the register information that we have overwritten the EIP. So the instruction pointer points to a register that is filled with these 55s, which is what we supplied in this Python command right here. Well, I mean, I tried to explain the concepts as best I can. If you don't understand anything, let me know. I'll try to explain it again. Okay, so we can see in the register information here that we've overwritten the instruction pointer. As far as we know, the instruction pointer points to the next instruction to be executed. Okay, and then we get some info on the registers. So this command in GDP, it lets us know what's in the memory registers, and it looks like we overwrote the the B register here, the EBX, and we also overwrote the base pointer. It's got all the stuff that we sent to it, and the instruction pointer has all the stuff that we sent. The base pointer was overwritten. Call master correct. So yeah, so we actually control 3 different registers with our buffer overflow. So the most important one, of course, is the IP register, and the IP register basically points to the memory address of the next instruction. So if we can control this, then we can do all sorts of nasty things. Okay, so if we want to imagine the process visually, then the process looks something like this. So we got the all of the program memory over here. When we did the Python command to copy a bunch of stuff to the buffers, it basically overwrote everything into the stack with those U characters. So this means we have write access to the EIP. This in turn allows us to specify to which memory address the EIP should jump. However, to manipulate the register, we need an exact number of U's up to the EIP so that the following 4 bytes can be overwritten with our desired memory address. So determine the offset. So this is another important thing when we're doing binary hacking, is that we need to figure out exactly how many characters we need to send, or how many bytes we need to send to the buffer to overwrite the IP register exactly. So the offset is used to determine how many bytes are needed to overwrite the buffer and how much space we have around our shellcode. Shellcode is a program code that contains instructions for an operation that we want the CPU to perform. The manual creation of shellcode will be discussed in more detail in other modules. But to save us some time, we're going to use the Forbidden framework that offers a Ruby script called pattern create. That's going to help us determine the exact number of bytes to reach the EIP. It creates a unique string based on the length of bytes used specifically to help determine the offset. So we're going to run this instruction over here, and we can't do this inside of GNU Debugger, unfortunately. Okay, let's go back. Let's quit. And then let's do the pattern create. No such file or directory. Oh. Well, I mean, we can do this inside of Kali Linux. So I got my Kali Linux here. So we created a file called pattern.txt with this command. It basically has a long string of pattern, well, like a pattern of different bytes that looks kind of like this. So if we were to find a pattern that looks like this inside of the memory, then we could figure out exactly where it is in the memory or how many characters in it is. So I'm just going to copy this. I'm going to echo this out to a file called pattern.txt. Buffer overflow. Yeah. Okay, so we created the pattern. What do we do next? So now we replace our 1200 U's with the generated patterns and focus our attention on the EIP. Okay, let me change my music. Just a second, everybody. Okay. So GDP using the generated pattern. So It looks like they want us to just copy it over. All right, no problem. Okay. Is this... Wait, is this Python 2? It looks like Python 2. Why are we using Python 2 in 2025? Okay, so the reason why we're using Python 2 in 2025 is because, well, Python 2 is actually a lot easier to work with when you're trying to develop hacking stuff for buffer overflow. Okay, so let's go back into the programmer here. Okay. So we're going to run with Python print this stuff in between some single quotes. FurnaceX says, to be honest, once you learn how to use B in Python 3, it's fine. Since all of the binx libraries have been fully updated to Python 3 for ages now. FurnaceX, hello, nice to see you here. And yeah, I think, well, I mean, you can get used to using bytes instead of Python. Actually, I've recently learned how to use Perl to generate shellcode as well. It's kind of fun using different programs though. Okay, we've got our pattern that we're going to send to the program here. So we do our segmentation. We get our segmentation fault, and we can. Let's see. So is it info registers? Yeah. So we just need to figure out what's in the EIP right now, and that's going to let us know how many characters in the offset is going to be. So the EIP has these bytes in here. Okay, we see in the EIP it displays different memory addresses, and we can use another NSF forbidden framework tool called pattern offset to calculate the exact number of characters needed to advance to the EIP. So pattern offset, I can run this inside of my Kali Linux here. So when you run the program, you basically feed it whatever's in the EIP, the value of the EIP, and it'll tell you how many characters the offset is going to be. So it says exact match at offset 1036. So 1036 is the offset we need to give in order to overwrite the EIP in this case. So we send exactly 1036 bytes, and then the next 4 characters are going to be the memory address of where we want the next instruction to go to. So if we now use precisely the number of bytes for these things, we should land exactly on the EIP. To overwrite it and check if we reached it as planned, we're going to add 4 more bytes with x66 to execute it to make sure that we control it. Okay, so this is the command over here. We're going to go back. So the program being debugged has already started. Started from the beginning? The answer is yes. Okay, so FurnaceX says Pwn tools also has a cyclic generator, which is handy. So Pwn cyc for CLI, cyclic, and cyclic bind. Yeah, Pwn tools is it's a very useful Python module that is used for for eWord development. But yeah, it also shows up a lot when we're doing these kind of binary hacking challenges. Okay, so we gave the 4 characters here, right after our offset of 1036, and we see that this is in the EIP now, which confirms that we have control over the EIP. So if we do info registers, we can see that the EIP now has exactly what we supplied to it here, which means we can start crafting our shellcode, or the whatever address we want to jump to. Okay, so now that we've seen that we've overridden the EIP with our 66 characters, next we have to find out how much space we have for our shellcode, which then executes the commands that we intend. As we control the EIP now, we will later override it with the address pointing to our shellcode's beginning. Okay, so we got another... okay, so we should probably VPN into... We should probably SSH into this box next. Okay, let's get out of here. Okay, what's the next machine? Let's start it up. Wait, have I started it already? US Academy 4? Okay, so we switched over to the... I mean, where's our... Hold on. I think I need to re-download my... But I'm already connected, right? I'm already connected. I don't know. Do we need to... Because we switched over our server, do we need to re-download the key? I think we might have to. Hold on, everybody. Let me get rid of my previous key. Okay, let's re-download that key. And let's start up the VPN again. Okay, okay. Let's start up the machine. Oh, it's already up. Huh, it's the same machine. I didn't need to. Why did I do that? Okay. Let's log back in. Hold on, I need to make sure it's the same IP address. Yeah, it's the exact same IP address. No route to host. Wait. Am I not connected anymore? Alright. So let's figure out if I'm connected. So ton 0. I've got this IP address on the HackTheBox network. I just need to make sure that I can connect, that I can communicate with this server here. I'll just try pinging it. Nope, can't connect to it. Okay, so... I'm going to try downloading the VPN file again. Or maybe I need to Maybe I need to terminate this machine first. Okay, so I'll terminate, download VPN connection file. Oh. Maybe I should, okay. Anyway, spawn the target system, download the VPN connection file, delete the previous one. Download the VPN connection file, okay. Alright, connect with OpenVPN. All right. And so wait until this thing finishes loading up, and then we'll see if we can connect to it. Cypher says, why do they always have dead beef in well, dead beef is just kind of a meme. It's kind of a hacker meme. It's a programmer meme, it's a hacker meme. But dead beef is one of those things you can spell out with text characters. That's why you see it. You see it all the time when you do hacker stuff. Okay, so we got our IP address. Let's see if we can ping it first. Okay, we can ping it, which means we can SSH into it. Let me get the password. And what do they want from us here? So we're going to GDB into this program, and then what do we need? Examine the registers and submit the address of EBP as the answer. We just need to examine the registers. So you can use, the program has no registers now. Okay. I think what they want us to do is do the overflow. So the overflow was with this command right here. Okay, now info registers. EBP is examine the registers and submit the address of EBP as the answer. After the overflow, EBP is this. I don't know if this is supposed to be the answer, but let's try. Common Master says, I found the SSH tool very useful. I learned it recently. So SSH is pretty much standard. So when you want to do remote login, you're almost always going to be using SSH, unless you're using some other thing. Okay. Congratulations, yay, that was the answer. Okay, let's move on. Man, that seems like a really long-winded way of making me just put in this. But anyways, let's move on to the next thing. Okay, determine the length of the shellcode. So now we should find out exactly how much space we have for our shellcode to perform the action we want. It is trendy and useful for us to abuse such a vulnerability to get a reverse shell. So the first thing we need to do is find out approximately how big our shellcode we're going to be using. Okay, and for this we'll use the Venom. So we want to do something like this. So the Venom can be used to do all sorts of great malicious actions. And one interesting thing about NSF Venom is that if you go to the revshells.com website, you can also create payloads for the Venom here. And it is very handy. This website is very, very handy. Okay, but we're not talking about that. We're talking about running the Venom here. So I'm just going to do this on Kali Linux here. And it looks like we're looking for a reverse shell on localhost, on the elite port. So platform Linux, architecture x86, format C. And when we run this command, it's going to give us some C code. FurnaceX says, dead beef indicated an invalid value on some really old IBM systems since it was eye-catching, and it stuck around ever since. Let's see. Blackshell asks, are we allowed to use the forbidden platform on the OSCP exam? Well, I mean, my information for the OSCP exam is pretty old, but I do believe you're allowed to use the forbidden platform once. You can use one module with the forbidden platform on your OSCP exam. FurnaceX says there are some other famous ones like Coco for heap hacking. I actually didn't know about that one, FurnaceX, but thank you very much for educating us on that. But yeah, this is the shellcode that we're looking for. So it looks like in this case the shellcode is 311 bytes. Sometimes you have a lot of room to inject your shellcode, and sometimes you really don't. Oh, one target machine. So when they say one target machine, it's actually more generous than once, because it means the target machine. That means that you can run any number of modules from the forbidden platform. Oh, that's handy information to have. Thank you. Okay, so where are we? Why does it say 68 bytes here? Wait, I did the same command. How come it says 68 bytes here, but when I did it, it was 311 bytes? That's... Oh, no, wait. The payload is 68. Okay, so the payload is 68. The size of the C file is 311. Never mind. There's some fake news here. Okay, so we know our payload will be about 68 bytes. As a precaution, we should try to make a larger range if the shellcode increases due to later specifications. Often it can be useful to insert some no-operation instructions, otherwise known as NOPs, before our shellcode begins so it can be executed cleanly. Let us briefly summarize what we need for this. So we need a total of this many bytes to get to the EIP. So we can use an additional 100 bytes for NOPs. Furnace, could you tell me why you don't like the recommendation of a NOP sled? I hear that the NOP sled is very useful, just in case the code doesn't execute what it doesn't execute. But let me know what your opinion is regarding the NOP sled. Okay, so we can use an additional 100 bytes for NOPs and 150 bytes for the shellcode. So we got the buffer, which is this. So the buffer is going to be the offset minus all of our parts. So it's 100, it's 150, and then it's 4. Furnacex says, I remember the guy who taught me buffer overflow said a kitten... Wow, that's Aaron, Aharon? Aaron, how did you learn Python? How did you learn Python? Is that the question right there? I learned Python by, well, I mean, I learned Python by doing a bunch of different courses, but if you want to learn Python, probably the best course for Python for beginners is Python Essentials. So this is the link right here. Okay, where are we? So we need to craft exactly the right amount of data to get the shellcode to execute correctly. Okay, now we can try to figure out how much space we have available to insert our shellcode. Okay, and did they just put the shellcode in here? Oh, they're trying to figure out... Okay. I think we can skip this part. So what do they want us to do here? Okay, so answer the questions. How large can our shellcode theoretically become if we count nops and shellcode size together? How large can our shellcode theoretically become if we count nops and shellcode size together? So, I mean, format is in 00 bytes. 00, so I mean, just type in bytes. Well, I mean, the shellcode they recommended was 150 plus 100 for the nops. So it's 250 bytes. Okay, that was unexpectedly easy. Okay, so we're gonna do bad characters next. Furnace says, okay, so the reason people use NOP sleds is because of the way. Oh, really? Okay, so the forbidden platform, the shellcode gets a pointer to the location and memory, which is going to overwrite some parts of the stack. Really? And NOPs work, but it's a very inelegant solution. Huh. I mean, what would you recommend for a more elegant solution than using a NOP sled? I mean, I'm not really I'm not really an expert on this stuff, but I'm interested to hear what your opinion is. Okay, so identification of bad characters. Previously in Unix-like operating systems, binaries started with 2 bytes containing a magic number that determines the file type. In the beginning, this was used to identify object files for different platforms. Gradually, this concept was transferred to other files, and now almost every file contains a magic number. 270 is now a HackerFrog. Thank you very much for following on Twitch. Let's give you a Hack the Planet. Welcome to the stream.
Hack the planet! Hack the planet! Shut up and get in.
Several reserved characters also exist in applications, but they do not always occur and are not still the same. These reserved characters, also known as bad characters, can vary, but often we will see characters like this. So they're null bytes, they're line feeds, they're carriage returns, and there's form feeds. Here we use the following character list to find out all the characters we have to consider and to avoid when generating our shellcode. Okay, so this looks like... Is this Python? This looks like Python compatible code. So to calculate the number of bytes in our characters variable, we can use bash by replacing the /x with the space and then use wc to count the words. Okay, so... Oh, this is bash. Okay. Let me copy that. Let's give this a try. So we're just going to define characters here inside of our environment variables. And then we use word count to determine the length of the bad characters. I expected a much larger number than just 3 for some reason. I wonder what happened there. Something went wrong. So the string is 256 bytes long. We need to calculate our buffer again. Wait, what happened here? So echo characters. Oh, you know what? I think something might have went wonky here because it interprets the bytes over here as ASCII characters. Let's see. Furnace says when the Forbidden Platform runs, it gets its memory location, basically overwrites the previous 2 values on the stack, and then it also puts more values on the stack. Usually those previous 2 values aren't modifiable, so you get a memory access violation. So what you can do instead is just move the stack pointer to somewhere that isn't allocated at all. For example, add a single add ESP minus 500 instruction is all you need to, instead of 150 nops. That's interesting. I'd love to see like an example of this. I wonder. Well, I mean, if you could point me at like a YouTube video or like maybe a blog that that talks about this, that would be great. Of course, you don't have to. You don't have to. I understand. Like it's a pain to dig this stuff up. But yeah, we're just gonna play. There is none. Okay. So the string is 256 bytes long. Okay, we need to calculate our buffer again. I got upset when I found out there's no good resources for it. 270 says, isn't the main reason you use a NOP sled is because you don't know the exact location, but you want to slide until you get there? I think the NOP sled is used because from my understanding, the NOP sled is used because there might be some random data between the shellcode and where the pointer lands. So we want to make sure that that there is a smooth execution. So that's why the NOP sled is used. So Furnacex says it's literally because people don't know why they need a NOP sled, and people are just told to add one. Okay. Offset also doesn't explain it very well in any of their courses. That's a call out. That's a call out if I ever saw one. Yeah. But I don't know. What we should do is we should probably spread the good truth. Okay, so let's see. Buffer, characters, EIP. Now let's take a look at the whole function. I think what we should do, because this looks like, I mean, it looks like Python syntax already. Maybe we should create a Python script. Let's have a look at the whole main function, because if we execute it now, the program will crash without giving us the possibility to follow what happens in the memory. We set a breakpoint at the corresponding function so that the execution stops at that point, so we can analyze the memory's content. Shout out to Peter from Coralan. To set the breakpoint, we give the break command with the corresponding function name. So break bofunc k. Now we can execute the newly created input and look at the memory. Okay, so we're working inside of GNU Debugger here. So break bofunc, and then we run the command. Why is it snipped off here? Oh, because they've got all that that weird bad character input. Okay, let me try piecing it together again. Okay, so Furnacex also says, also adding random NOP sleds makes your payload super detectable by EDRs, and mostly shows that you don't understand what's going on in the very low level. Which is fair, since people don't really learn stack hacking from a very low level standpoint. It's usually taught top down. Here's a hack, just do this magic if you run into this issue. Right. I've never challenged this, and I mean, I think it's a valid point. If we don't have to use the NOP sled, we should probably learn why we don't need to and how we can avoid using it, for sure. Okay, so let's see, where were the bytes? So the bytes were this. Let's paste in all those. Let's paste in all those bytes. And what else do we need to include? And then we need to add the 66 bytes. Okay, let's do that again. Well, let's do that in the first place. What happened here? Command substitution. Command substitution. Ignored null byte in input. Ignored null byte in input. Black Shell says, do you think there's a demand for malware analysts? Well, I mean, I'm pretty sure there is a demand for malware analysts, but you have to really know your stuff in order to be hired as a malware analyst. I'm pretty sure. Malware analyst is it's a pretty prestigious job inside of cybersecurity. I mean, if I were to ask really quick, like, this is not at all something that that I know very much about, but if we were to ask the AI for fun, okay, so what skills should you know to qualify for a malware analyst's job position? So just keep in mind that that this is AI, and it's not necessarily going to have all the answers, but this is just, kind of a ballpark. Sank Logic, hello, nice to see you here. What is up, Shy Hat? Malware analyst is hard AF. Well, I mean, you really have to, man. I certainly couldn't do it, because you need to know a lot about programming. And you need to be able to program in a number of different languages. Let's see. Aaron says, "What's the most uncensored LLM?" So most people consider DeepSeek to be the most uncensored LLM because it doesn't really censor. It'll basically tell you whatever you want, as long as it'll tell you whatever you want as far as hacking is concerned. I don't know about stuff like, about violence or anything like that, but it certainly doesn't have a problem telling you about hacking stuff. Okay, so fundamental cybersecurity knowledge, reverse engineering and static dynamic analysis, programming and scripting skills. So assembly, you need to know a lot of assembly for different architectures, and Python probably less, but most of the stuff, whatever language the malware is written in, you need to know that language. Otherwise, you're going to have a very bad time. Ken PDX says, I have a paid version of ChatGPT, and it doesn't censor me at all, at least not with this kind of stuff. Learning C now, but yeah, I mean, I think if you're just learning how to do reverse engineering and binary hacking, C is probably a good language to learn, because most of these beginner challenges are written in C. But let's go back and let's see if we can get this command working. Okay, run the thing. So after we've executed our buffer with the bad characters and reached the breakpoint, we can take a look at the stack. Okay, so ESP plus 5. Why are they taking a look at ESP plus 500 all of a sudden? Master says, I used to build makefiles and use a lot of shell commands, but I never thought about using Python inside the shell. So I mean, this is just what they're doing inside of GNU Debugger, and it's a pretty good idea because you can do all sorts of fun stuff with Python. Okay, so we crashed the program. What are we looking for here? So where the X55s begin is, well, it says it's B2. This is not the same on my machine. Oh, you found a blog post. Okay. Let me go ahead and copy that. Thanks. I've got some reading material for later. But yeah, thank you very much, Fernosec, for sharing that knowledge with us. Okay, so what? I mean, So here we can recognize at which address the X55 hexes begin. Where we can, from here we can go further down and look for the place where our characters start. So the characters begin hex 01, hex 02. Where are we? Well, I mean, for us, it starts over here. So we see hex 01, hex 02, all the hexes over here. That starts after our big buffer of X55 characters. Okay. If we look closely at it, we will see that it starts with X01 instead of hex 01 instead of hex 00. And we've seen some warning during the execution that the null byte in our input was ignored. So we can note this character, remove it from the variable characters, and just adjust the number of our 55s. Okay, so what are we doing? We're running the same command that we did last time. Okay, so we're running the same command that we did last time, except that we're omitting the null byte here. So we omit the null byte, and then we add one to this over here. Okay, and then we run it again. And what happened? Okay, so we note this character, remove it remove it from our variable cars, and then adjust the number in our hex 55. Okay, so send the characters without the null byte. And then we take a look at the stack. So here it depends on our byte's correct order, the variable. It interrupts or skips the order. Now that we recognize, okay, so let's go ahead and take a look at the stack. So we're looking for an interruption in the pattern. 1, 2, 3, 4, 5, 6, 7, 8. Oh. Yeah, something funky happens after the hex 08. Okay. Sonic Logic says, you've been on for 3 hours. You're a grinder. Well, I mean, the streams usually go on for about 5.5 hours, but yeah. I'm just gonna try to get to the end of this section, and then we'll pick up next time. but we'll be switching over to another topic. We're not going to be ending the stream. Okay, so here we expect hex 09, but we didn't see it. So it's probably hex 09 that's the bad byte. So now that we recognize that after hex 08 we encounter null byte instead of hex 09 as expected, this tells us that this character is not allowed here, must be removed. So we get rid of hex 09. Okay, so let's do that. Alien, hello, nice to see you here, and yeah, catch you next time. Let's give you a Nyan Cat to see you off. See you later, Alien. Okay, so for a sec, I missed a message. Why not just use an instruction to push the ESP further away? Finding bad characters is so annoying, especially two-character combos. Yeah, bad characters is certainly my least favorite part of doing binary hacking, or these buffer overflows in general. Okay, so let's quit out of here. I'm pretty sure that there's not going to be very many bad characters in here, because they wouldn't do that to us. Okay, so we're just going to add one more to the offset, and then we're going to remove the X09, the hex 09 character. Okay, and then we run the thing again. Okay, and then we need to inspect the stack. Okay, so 5. Whoa, what happened here? So 9, it should go from... The A is missing. The hex 0A is A character is missing. I think they're going to talk about it. Okay, this process must be repeated until all characters that could interrupt the flow are removed. Yeah, hex 0A expected, but it's not here. So let's remove that one as well. Okay, one more time. So we remove hex 0A. And we do the same thing. Oh, jeez. Furnace 6 says automated x64 debug using Python by submitting input, then automating extracting the stuff in the stack, and then checking for bad characters. Still took a couple of hours to do all... That's a lot of bad character tests. It's better than wanting to slam your head into a desk. That's true. Automate the boring stuff, if you can. Okay, let's inspect the stack one more time. Okay, here it is. So we just need to manually inspect this to look for characters. Let's see. B, C, D, E, F, 1. So after, okay, so A. I'm just gonna go and look at the, looking at this stuff super hard makes my eyes hurt. Okay, so find all the bad characters that change or interrupt are sent bytes order and then submit that as the answer. Oh. We need to keep track of the bad characters? Okay. That... I'm hoping that, let's see. What characters did we remove? Okay, so we removed 9. So it's 0009. I think 0A? That's not the correct answer. I was hoping it would be that short. I guess it's not that short. Okay, let's look at the stack. All right. Let's carefully look at the stack. EF 0. This music is not helping. Everything seems okay so far. We should see a pretty constant pattern here if it's uninterrupted. Wait, something happens over here. Yeah, something happened over here. Seven, 8, 9. A. This is so not fun to do on stream. Let's see. A, B, C, D, E, F. So it goes up until FF. This is hurting my eyes. Okay, I'm gonna feed this to the I'm gonna feed this to the AI, and maybe it can spot something. This is what AI is made for. Okay, can you spot any weird gaps in this hex pattern? Okay, expected behavior, potential oddities, null bytes. Okay, I mean, it didn't find any gaps in this page. Let me get the previous page. Well, I mean, I don't necessarily recommend it. It's just the one that I use. You can use whatever LLM you want. If you want to use Claude, if you want to use ChatGPT, if you want to use DeepSeek, just use the one that. It's not the complete hacks. It's not the complete hacks. Okay, how about missing hexes? Missing hexes and weird patterns from this output. Okay, we got ads running on Twitch, so we run them on YouTube, and we also put on some birds. Let's do... This one's not a bird, but it is a happy squirrel. Enjoy the happy squirrel. We'll be back in about 15 seconds. Gotta take a water break. So yeah, there are a lot of squirrels in the neighborhood over here. Lots of trees. I used to feed the squirrels, but it's if you feed the squirrels, they just come back for more. So I try not to feed the squirrels as much these days. Okay, so what do we got here? So often avoids 00090A20. 20. Okay, that's probably the missing one. Let's check to see if it's missing. So 20 is not here. Okay, let's feed this to submit. Yay! Done! Okay, great. Alright. So we're probably going to be moving on to the next activity after this. Okay, so this is going to be the part where we actually generate our shell code. But we're going to have to put a pin in this because I wanted to do some pivoting practice. So we've got Dockerlabs over here. It's one of our favorite websites for learning about network hacking. These are little Docker containers that you can put on your own device and then deploy them on your device and then do hacking against them. So we've got this machine called Little Pivoting. I'm hoping that we have to do some pivoting to finish this challenge because I have kind of forgotten how to do pivoting. So pivoting is basically redirecting network input and output. I need to teach myself how to do this again. So hopefully I can do this box and it'll help me out. Okay, so let's start the challenge. So we're just going to get out of HackTheBox. We'll come back to this next week. What's your preferred tool set for pivoting? I really liked using SS Shuttle. It was very, very easy to use, but all the cool kids are using Ligolo. Yeah, that's what I've heard. It used to be that Chisel was the tool that everybody liked to use before, but that was a couple of years ago. Okay, let's go ahead and start up the Docker container. So we got little pivoting over here. I'm gonna unzip the thing. Ngrok played with that a bit. Ngrok for pivoting? I don't know. I don't think I've never used it. So auto deploy. We're gonna auto deploy little pivoting. No. Oh, I need to make the script executable first. Okay, chmod. Now run the thing. Ngrok is mainly used for exposing stuff to the internet. I guess you could use that for pivoting. It's a bit sus. Well, I mean, I've never really exposed anything of my own to the internet because I'm afraid that somebody's going to come in and ruin my day. Okay, so there's an error in the laboratory. Huh, let me translate this message. I'm sure if I read Spanish, I would have a better time. Creating the pivoting one network would subnet this and gateway this. The pivoting network has been successfully created. Oh, wow. They created a whole subnet. Little pivoting.tar, no such file or directory. Wait, what happened? Little pivoting.tar. Okay, so we're just going to wait for this to undeploy. And I just need to make sure that little pivoting.tar should have been unzipped. Yeah, we wanted to replace that. Wait, which one is little pivoting.tar? Is there something missing here? Hold on. I guess little pivoting has multiple containers, trust, upload, inclusion. But I mean, it looks like the script is looking for a file specifically called little pivoting.tar. Let me try running it again. Okay, chmod plus x auto deploy. And let me take a look at the auto deploy script. So what is it looking for? So it creates a network called pivoting1. Hold on, let me take a look at the error message one more time. So the error message we got looked like okay. Oh, we don't do little pivoting.tar. We do it on these other ones, trust.tar, upload.tar, etc., etc. So which one is the first one then? Checking changes says, did you make the frog yourself? Yeah, are you talking about the model? The model in the corner of the screen? Yeah, I did make that one myself. But, Trust.tar, upload.tar. Do we just run the autodeploy.sh script? Oh, okay. So you're supposed to do tar archive 1, tar archive 2. So we've got 3 tar archives. We got inclusion, trust, and upload. So we would run trust. Well, let's do it in order. Inclusion.tar, trust.tar, and upload.tar. Okay. Checking changes says, I tried using Electron.js and it screwed me up. I'm sorry, I don't understand. Python, keep up the good work. Okay, so we've got 3 machines running here. So I guess we can do 3 layers of pivoting. That sounds like a lot of fun. Okay, so we got the machines running over here. Let's see what we can access from the outside. No, it's not what I want to do. Okay, so there's the Docker container network over here. And the network they created was the 10.1, I'm pretty sure. Is that French? No, it's Spanish. It's Spanish. Checking Changes, just subscribe. Thank you very much for the subscription on YouTube. Checking Changes. Let's give you a Hack the Planet. Welcome to the stream.
Hack the planet! Hack the planet! Shut up again!
Okay, so I think the first machine that we're supposed to be accessing is pivoting 1 on this IP address right here. Let's see if that's the case. So just run an nmap scan on it. Okay, is that not the IP address? Maybe it's not. Hold on. Let me... Is it this one? Okay, this is the one. This is the one. So I think... Is my IP address on... Yeah, okay. This is my IP address. And the IP address of the jump box... Well, I'm assuming it's a jump box. It's going to be this one right here. So there's only port 80 and port 22. And we should probably check out port 80. It's a Debian default page. Great. All right. Let's check it out. So this is the Debian default page. Let's take a look at the web page source. There's usually nothing here. It's just... Yeah, there's nothing here. Okay, so from here, we should probably check to see if there's a robots.txt file. Nope. What else can we do? I guess we can do some web app enumeration. So we can run dirb on the machine. Just to see if we can identify any endpoints. Okay. So, ooh, shop index.php. That, okay, so we need to access this. Maybe, well, let's just take a look at it first. This might be a long process. There's supposed to be 3 different containers. What? System error, get archivo? Archivo equals... Let me just try some local file inclusion for fun. Wow, okay. So we just, yeah, so from this error message over here, I got the sneaking suspicion that archivo was a URL parameter. So I put the URL parameter in the page here, and I tested it for local file inclusion. Truly an LFI of all time. You know, I mean, they have to make it easy for us because the goal of the box is to teach pivoting and not local file inclusion. Okay, so we want to figure out what users are on the system. So there's a seller, Manchi and seller. This looks like these are not standard. So I don't know. We could try downloading. We try looking for SSH private keys. So if these users have SSH private keys, we would find it like this inside their home directories. So home seller .ssh ID RSA. No. The other user was Manchi. Nope. I'm not too sure what other files we could start looking for. So seller, Manchi. I guess we could just do some brute forcing attacks, because we've got these two usernames on the list. Let's see, brute force attacks. We're gonna add these two names to our list of usernames. So there's Manchi and there's seller. And let me double check the spelling on those. So seller, Manchi, yeah. Okay. So we're going to use ncrack to do an SSH brute force attack. Tom Bean asks, how many hours a day do you spend hacking or doing CTFs? I mostly do CTF stuff on stream these days, but I guess how many hours a day? I don't know. When I'm streaming, it's something like 3 or 4 hours per day, but when I'm not streaming, not as many. That's my answer. Okay, so let's go ahead and do that brute force attack. We're going to brute force attack the two names in the users.txt file. We're going to use the RockU password list with the 14 million passwords, and we're going to see if we can get... Oh, it's a capital T. Oh, it's... This is not the same thing. I mistook this for Hydra for a second. Okay, we got ncrack running. We might be able to brute force a password out of here, but I guess we should look in some other places just in case. Have you checked for RFI or log poisoning? So, I haven't checked for RFI yet. I guess we could. We could do that right now. So I don't know, echo out this is a test to test.txt, and then we'll stand up. Did it say discovered SSH cred? Did it? Oh, we did. Okay, we discovered credentials. Okay, so we just discovered credentials using our brute force attack, so we can log in as the Manchi user. Let's do that. Well, I mean, you know, I think they're making the initial access easy for us because we're supposed to be doing, well, there are like 3 different containers here. So, what was the IP address? This. Okay, so it's lovely, and we're in. Alright, so I guess we can call in Scary Hacker Voice Man to talk about how we got into this box. Just a second, everybody.
Hey everybody, it's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes out every time we compromise a server, and we just compromised this one. Well, Mr. Little Pivoting Administrator, it seems like you like having insecure applications with local file inclusion on them, huh? Well, that is a big mistake. We managed to use your local file inclusion to read the etc password file, which has the usernames, After that, we did some SSH brute forcing and found a password for the Manchi user. Maybe you knew about these security flaws in your system, or maybe you decided to accept the risk. Well, you accepted the risk. Ha 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 ha. And now we're in.
Okay, Defus says, you could try PHP filter chains on that LFI. Seems like a pretty new machine, so maybe they took care of that. PHP filter chains. What is the payload for the PHP filter chains, Defus? If you could let me know, I'd appreciate it. Sank Logic, hell, oh, you're here on Twitch. Awesome, nice to see you here, man. If you're not a man, I apologize, and I will refer to you by whatever you like me to. Anyways, what are we doing? Let's give you a... Not a Twitch dude. No worries, no worries. Let me give you a Yancat. Okay, so we don't have sudo here. Maybe the goal isn't to get root user on this box. Maybe it's just to pivot to the next box. So how would we figure that out? So I haven't done any post-X stuff in a really long time. Python 3 filter chain generator. Oh, interesting. I've never seen this attack before, Defus, but it's something I should probably look into. Let me copy that link. I got lots of stuff to read after the stream is over. Okay, so what would you do to figure out what connections we have on this machine? Was it IP tables? IP tables? What is that? What is that? Need to look this up I haven't done this in years. Linux. What is the name of that table? I guess we could do IPA. IP, there's no IP command. There's no... This is a Docker container. They don't have very much. Netstat. There's no netstat. There's no SS. I guess we should probably be doing our pivoting from here. So if we want to pivot from here, I would usually use something like SS shuttle. And let's see if I can look that up. Shuttle. There we go. Okay, so to run sshuttle, you need to have... To use sshuttle to do port forwarding, you need to have Python installed on both of the targets. So let's see. Let's see if there's Python here. Let's see if there's Python 3. There is Python 3. Diva says it's pretty new and it's made 80% of all LFI challenges super easy. Huh. Wait, does that mean you can turn LFI into RCE? You can turn local file inclusion into remote command execution? Era says, I'm so late to the stream. No worries, no worries. We're here to, if you're busy doing 4th of July stuff, it's totally understandable. Oh wow, that's really interesting, Divas. Thank you very much for letting me know about that. I'm gonna have to keep that in mind the next time I find some LFI. Okay, so, we got Python. We can probably use SS Shuttle. And okay, so this is how you use SS Shuttle. Let's get out of here first. Actually, yeah, I think we can get out of here. So SS Shuttle, we're using... Actually, wait. SS Shuttle requires us to... IP route sync logic, yeah. Hold on. Let's get back in. Okay, IP, well, I mean, I'm pretty sure there's no IP command here. There's actually very little on this box because it's a Docker container. So we need to figure out how to, we probably just need to do some nuke it, yeah. That's what happens. Okay, so what should we do? Should we just Okay, so what other tools could we use for which SSH? I mean, there is SSH on the box, obviously. What other tools can we use for pivoting? So procnet root, yeah, I've never done that one before. It's procnet root. These aren't standard IP addresses. It's hex, but these are the IPs. Okay. Destination, gateway, flags. Okay, so how do we convert this from hex to decimal? Hex to decimal. Hex, well, I mean, maybe I'm looking for something like hex to IP address. That seems kind of verbose, Defus, thank you. Okay, we're gonna run some ads on YouTube because they're running on Twitch right now, and we're gonna put on some birds. How about... these birds? Okay, we'll be back in about 40 seconds. Just have to take a little water break. Oh, sorry, I was muted. Jeez. Okay, so, what do you think about this course? War Games something something course. Hold on, let me take a look real quick. Well, I mean, it really depends on how much it is. If it's expensive, then I'd say no. But how much does it cost? Because I mean, you can get all sorts of stuff for free online, Grunt Play. Anyways, let's take a look at this course real quick for a second to see if. Oh wait. Okay, this is a binary hacking course. Okay, so it gives you certificate. Okay, so C fundamentals, reverse engineering, memory corruption, shellcoding, ROP stuff. I mean, give me a guide to get it for free. So $150 for active students. The good thing about having a course like this is that all the stuff you have is in one place. If you wanted to do this for free, you would probably need to cobble together your resources from a bunch of different websites. But if you can afford the $150 to pay for this course, let's see. Next Friday. Wait, are you trying to take this to? When you say take the OSCP, do you mean take the exam, or do you mean sign up for the course? You want to take the course after the OSCP. You're taking the OSCP exam on Friday, next Friday. But yeah, you don't need to do any buffer overflow. You don't need to do any binary hacking for OSCP anymore, because the OSCP is mostly Windows Active Directory now. Yeah. I mean, if you like the content, if you're interested in doing binary hacking stuff, then yeah, go for it. I will say that you could probably get all the stuff that's inside of this course for free if you do a lot of hunting around, but you probably save a lot of time hunting around by taking the course because it's all here. But yeah, that's that's my answer. $150 is not, well, it's not super cheap, but at the same time, it's if you can afford it, go ahead. That's what I say. I'd rather do it for free because college subjects aren't enough. Oh, okay. Actually, no, wait, Grunt Play. No. You don't need to use this course. This is what you do instead. You just do Pwn College. So Pwn College here, they've got a lot of binary hacking and reverse engineering stuff. Yeah, Furnosec. You beat me to the punch. Yeah, unironically, I don't understand. Wait, what? Grandplay says, I don't understand Pwn College. Unironically, I know Pwn College. Wait. When you say you don't understand, do you mean you didn't know about it? I don't understand Pwn College, like literally how to learn from this platform. Oh, well, I mean, I could give you a little short tutorial. You basically you want to use a couple of different user tabs, one for your dojos and one for your workspace. So usually when you're doing this stuff, the workspace is either going to be, it's usually going to be the desktop over here. And the great thing is that all the virtual machines are, well, I mean, Pwn College is free, and that's the most awesome part about it. It's also very, very in-depth. For example, you go to the dojos, you go to like program security over here. there are, well, in each one of these modules there are a bunch of different levels that you can hack against. It's so good. It's so good, but unfortunately I can't stream any of the materials from Pwn College online because they don't allow it. But if I could, I would be doing this all day on stream. But yeah, I mean, definitely try out Pwn College before you consider buying that course. Grandplay says it's really unfriendly to anybody. Let's see, AppSec, and I didn't get that website. Each one of the topics on Pwn College have sections that are lectures and reading, right? It's not like HackTheBox Academy. It's they don't hold your hand as much as they hold your hand less than HackTheBox Academy, and they hold your hand less than TryHackMe. But it's definitely a really good resource. But yeah, let's get back to whatever we were doing over here. So we just got our network range over here. What we want to do is we would like to do some if we cheat, we actually know that this is the IP address we're looking for. But if we didn't know, because we didn't stand up the infrastructure ourselves, we would probably want to do some Nmap scans. And what we would do is probably upload our own Nmap binary. It's it's Spanish, so the website is Spanish. We got it from Dockerlabs.es. It's a Spanish website. So where's our static binaries? Let's see, locate Nmap. So I'm pretty sure there's a static binary version of Nmap somewhere in Kali Linux. Otherwise, we could use a Python script. Grenplay says, never heard of that platform. I'm technically, well, I mean, I don't. Do you know a lot about the Spanish, about the Spanish-speaking InfoSec community? To be honest, before buying the Ret 2 course, have a look at the Pwn College content and see if there's something you're actually interested in. Because stack and heap hacking is definitely not for everyone. Yeah. I'm in a Discord and most of them are from Madrid. The person who created Dockerlabs is actually a very famous person in the Latino InfoSec community. So the person's name is Pinguino de Mario, I think. Yeah, El Pinguino de Mario. And this is their YouTube page over here. Actually, they've got a bunch of stuff in it. Well, I mean, I can't understand any of this stuff, but it looks like this person knows what they're doing. Fernosec says, I have to head off for a bit. Hopefully you're still streaming when I get back. Fernosec, good luck with the pivoting on the box. I'll have a lot of fun. But yeah, Fernosec, why don't you have a Hack the Planet for the road?
Hack the planet! Hack the planet! Shut up again!
Grantplay says, I know him. He has a horrible video on buffer overflow. Really? I'm sorry to hear that. But yeah. Let's get back to the hacking. Let's see if I can find the other thing we could do for network for machine discovery is probably some sort of Python script. Let's see if we can get one from our good friend, I don't know, Claude AI. He doesn't explain anything. He just teaches you how to pass the OSCP buffer overflow. I mean, that stuff is really old. I mean, the stuff still works, but it is really old, you're right. Okay. So write Python code to do a ping sweep of a network range. So I'm not too sure whether Python is the better choice for this, or if doing like a bash script is better. Rampley says, it pisses me off that I have all the theory to really get it because of college, but we studied memory in the old school way using volgrind. I've never heard of volgrind. I probably have a bunch of ping sweeping. Actually, you know, we could probably find something online too. Okay, Python ping sweep script. Oh, it's for memory. It's for memory leaking well-known software. I mean, there's a lot of well-known software that I don't know anything about. If it's actually, I mean, I'm not surprised if it's some well-known software that I know nothing about. Is it for? Does it run on Windows, or is it on Linux as well? How to ping sweep your network with Python. Okay, let's go ahead and take a look. I hope you've got code. Ping3 module? I don't like stuff that uses custom. No. Fast ping sweeping in Python. Okay. Oh, cool. So for I in 255, do ping 1, grep bytes. You probably had that in your notes somewhere, didn't you? Okay. Let's get back to it. Let's try this out. Do you want to ping broadcast then B? Do you want to ping? Okay. Ping broadcast address. Okay, so there's 2 and there's 3. I mean, I'm guessing that it's just that it finished off, which means that there's only 2 and 3. I'm pretty sure this machine is number 2, and then there's number 3. Okay, so let's catch up with chat. Ellipsis says, I have a memory leak. I can't remember anything these days. Okay. Use Go, it's just so much faster. Well, I mean, doing like a /24 address shouldn't. It usually doesn't take that much time. SankLogic says memory debugging, memory leak detection and profiling. Use it with multi-threading and dividing and stuff. Okay. Ask Claude. Well, I mean, yeah, we've got these two addresses right here. So there's 2 and there's 3, which means next we should probably do some. How do we do port scanning? Port scanning, I don't know. It's probably easier to just upload like a netcat binary. Let's try that. Hold on. Let me change up the music. Can you pivot with Ligolo? I haven't used Ligolo before, but you know, we might come back and try some other pivoting techniques later. There's always a first time, that's true. Okay, let's try nmap precompiled binary. So static binaries for nmap, okay. All right, let's, oh, this is just an executable file. Let's see. Okay, there's the program there. Let me copy it to somewhere. Legolo for, It's about pivoting, not putting static binaries on compromised machines. I mean, that's true. That's true. Okay, well, I mean, Legolo, I think the latest one is called Legolo NG. I can look it up. Okay, so Legolo NG, an advanced yet simple tunneling something something. Learn the stuff. Oh, you learn the stuff for CPTS. Oh, do you already have your CPTS, Gruntplay? Tunneling like a VPN. Yeah, okay. Well, I mean, if you Grunt.AR is your portfolio. Took 4 days. PMPT is the oh gosh, what is the name? TCM security certification, right? Okay, so how do we use this thing? Simple, lightweight, fast tool that allows pen testers to establish tunnels from a TCP TLS connection using a TUN interface without the need for socks. Okay. So, do we need to upload anything to the target? How to use? Does it require administrator root access? On the agent side, no. Everything can be performed without administrative access. However, on your relay proxy server, you'll need to create a TUN interface. Supported protocols and packets. Great. Okay, how do we install this thing? CPTS is more, well, CPTS is more advanced than PNPT. Yeah, the PNPT is like the EJPT, really? Wow. Sudo apt install, could it be that easy? Or we could just, you know, type in Legolo NG. Sudo apt install Legolo NG. Okay. It's not installed, but it's in the repo. So can we run it now? Legolo NG. The maintainer is, yeah. I'm a big fan. So is it just Legolo? Is it Gigolo? No, it is not Gigolo. Okay, so I mean, is it installed now? Legolo NG. No, okay. I mean, did they abbreviate the command? How do we use the darn thing? Feel free to use the notes. Yeah, okay. Let me take a look. I think you need to make a build in the directory. Okay, first time for everything. Let's take a look at the notes that that Gruntplay has so generously offered. Ah, okay. All right, let's take a look. Mexican's not a language. Spanish is. Are you talking about, Actually, okay. Well, Mexican is a type of Spanish. Mexican is a type of Spanish because Mexican has its own slang and its own terms that they use. So Mexican is a type of Spanish. Mexican is Spanish. But yeah, I hope that is accurate. Okay, so let's see. We need to... Can we... Legolo NG agent, connect attacker, something, more or less. Ah, okay. I didn't want to be... Legolo proxy self-cert on your machine. Okay, so... Creating a new one, enable the web UI. I don't think we need the web UI, do we? Okay, so we got Legolo running over here. And then we connect it using the Legolo agent. According to SankLogic. SankLogic, hello, nice to see you here. And thank you for the commands. Alright, so do we run it from here? Or do we run it from the command line? I've never used this. I've never used the program before. Okay, so... Legolo agent, connect our IP address. So our IP address is this one, I think. You need the pre-compiled agent binary. Oh, it's like... Okay. Let me... It's gonna be fun figuring this out. The Legolo NG releases. Okay, let's go over there. These things, right? What are we looking for? We're looking for Linux AMD 64. That's probably what the target is using, right? Let me check really quick. Cat or uname A. Uname, yeah. Okay, so this is... Why does it say Kali? That seems kind of weird. But this is, yeah, it's a 64-bit Linux system, AMD. Agent for, yeah, that makes sense. Alright, so... Linux, AMD 64, what's the difference between these two? Okay, we downloaded the thing, so let's move it to our current directory. Okay. Let's see. I'm really sharp with all this stuff because of OSCP. Oh, OSCP has a lot of... I mean, I don't remember OSCP having a lot of pivoting stuff. Okay, so let's see. Let's gunzip it. Is it gunzip or is it something else? Okay. Wait, now it's a tar file? Now it's a tar file, we need to unzip it further, okay. Tar... Man, what is that command? Oh, CPTS has... Okay, okay. CPTS has, two machines where you have to pivot? Or it's something else? Tar unzip. I keep on forgetting it's XVZF. Okay. XV. Not in gzip format. This is a tar archive. Okay, so XZF, right? Okay. XZ. Oh, XF. So what did it... Are we taking a look at... Are we looking for this agent thing? It's just open. Open? Wait. Well, I mean, we could just do XDG open. Said the little agent to the victim. So is it just the... I mean, is it just the agent file? Okay, so it's just the agent file. All right. Let's host this. So Python m server 80, and then upload it to the target. Okay, so let's move into the temp directory for this. Which wget? We got wget. Okay, so 10.10.10.1. I think this is it. Hold on. Okay, we got those files. All right, there's ads running on Twitch right now, so we run them on YouTube. Enjoy the birds. We will be back in just about 60 seconds. Okay, come on out, my woodpecker friend. Where are you? Okay. All right, it's water time. Cyber Dante, wow, you're on YouTube. I didn't know. That's a cute bird. This is a northern flicker woodpecker. They are really handsome little guys, and yeah, they got the spots. They got the black bib. They have the red mustache. They're they're really cool. They're really cool birds. Cyber Dante, you've got stellar jays in your area? You must be on the west coast. Or near the west coast. Anyways, let's go ahead and put the birds away. Let's get back to the hacks. We don't have those ones. Oh, we got magpies. Huh. I mean, if you're on the west coast, they don't... I don't think they go down as far as California, but they are in Oregon. Oh, right, Seattle area. Yeah, that makes sense. Okay, so let's get rid of the other agent file. And let's make this executable. Okay, so we got this. It's executable now. Fernarius. Fernarius? I don't know what that... I don't know what Fernarius is. But magpies. Magpies are super cool too. If you got magpies in your area, they're really cool birds. Little birds. Okay, so what do we do now? So Agent Connect. Oh, really? Oh, really? Okay. So Gruntplay, I see your command there. Let me give it a shot. Well, I mean, is this the default port, or is the port going to be different every time? Okay, so this is the IP address on Cali. Red robins, they make their nest with dirt. Default port. Okay, let me... Connection established. Okay, so if that's the default port, then everything's working. Wait, so how do we run our commands here now? So agent joined. So do we just... How do we run our commands through the machine? Press enter. Type session command. Specify a session. Session 1? Okay, so we got our agent on here. I mean, can I just run my commands now? Auto root. Auto root. No root selected. No root selected. Oh, okay. Create new interface using existing one. I'm sure. Let's use an existing one. And oh, which interface are we supposed to be using here? Hold on. Let me figure out which one it is. I'm pretty sure it's this one right here, BR whatever. Okay. Creating routes, start the tunnel. Jeez, there's so much stuff to know about this. Bro's about to kill the network config. Am I? I can always revert back to a previous snapshot for Kali Linux. Failed, unable to start tunnel. Unable to start tunnel. Create a new interface. Generating a random interface name using interface name Immortal Lockjaw. Okay. No, no, that's just a device. Make a new interface and start the tunnel. I mean, I'm not able to create the tunnel in this case. I'm not sure why. But, Can you root the machine? I mean, do we need to root the machine to start it up? It's not usually the case. It's not usually the case where we're able to root the jump box, but I guess we could. Maybe there's some IT table stuff. Maybe. Well, I mean, if we can't use Legolo NG, we could probably just we could probably just do an SSH tunnel. And I don't really remember how to do this stuff either, but there was a lot of information over at TryHackMe at the Wreath room. Not found, huh? Have you started the proxy with sudo? Oh, we need to. I mean, maybe I forgot to. Maybe I didn't use sudo to create that thing. Hold on. Let's exit out of here. Yeah. Okay. 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 Maybe it was because I didn't start the proxy with sudo. All right, let's try connecting again. Okay, and then we do, what was it? Okay, so we got our agent. We do auto root. Create new interface, start the tunnel. Unable to start tunnel, file exists. File exists. Use my notes. Need to proxy first. Need to ton interface, remove the tunnel. Remove the tunnel. So you should not tunnel 10.10.10.0. You are on that. Okay. Okay, so let's see. Trying to figure out how to use Legolo. Agent kill, remotely terminate an agent. Well, okay, so this thing disconnected. You should just auto root and don't select 10, only 20. Oh, okay. Well, I mean, all right. Session, no sessions available, need to connect. Let's connect that thing. Okay. And then auto root. Select only the 20. Space to select. Okay. Use a new interface. Start the tunnel. Okay. Well, I think we should be okay. We should be okay because we started up our tunnel. So if we have our tunnel up, now we can do what? Are we connected now? Now the 20 network is like you have access to it. Go to another terminal. Okay, okay. So if we... Let's just do some nmap then. Wait, does nmap work with this? Or... Because a lot of stuff, well, a lot of tunneling stuff doesn't work with nmap. You can navigate like a VPN. Okay, so it's 20. Everything works, it's just like a VPN. Okay, let's take a look. It's 2020, right? So this is the ping sweep right here. We just want to make sure that we got access to this stuff. Over here, okay, so we can contact it. So we know that there's a 2 and there's a 3. We got our Nmap scans. Nmap it's taken a really long time. Actually, I think so host is up. What? Why does it report that host is up for all this stuff? That's not right. Okay. No, I mean, no worries. We're pretty sure that we're just gonna run an Nmap scan. We're gonna do like a full port scan on, I think, yeah. I think it's the number 3 machine that we need to contact. (2020-23). There's port 22 and there's port 80. So that means we can check out the web page. (2020-23). This is a Debian default page. Wait, is this the same machine that I contacted earlier? Okay, derb 2020-23. Okay, so I mean, it's not the same machine. Yeah, no, I agree that Legola is very cool. If, I mean, are there any scenarios where it doesn't work? That's the only issue. I mean, you know, I like using all the cool tools, especially if they work well. But everybody, well, I mean, strong firewall. Okay. I think everybody seems to use Legolo instead of Chisel these days because they don't like dealing with Chisel. They don't like dealing with proxy chains. Oh, okay. Yeah, security operation centers and EDRs. I mean, I don't know if you would use this in like a professional setting. Hard to know. Okay, what were we up to? So we got this going on. We probably want to do some directory busting. Let's try. Actually, let's do some Nikto for fun. Okay, we got some Apache. We got the website here. It's the default Debian one. There's probably nothing in here. Yeah, probably nothing in here. It's a professional tool. I've never used Pivot in my work. I just do AppSec. So, I mean, yeah, you're not usually not pivoting if you're doing web app stuff. It doesn't make too much sense to do it in that case. I guess pivoting in when you're doing AppSec is like server-side request forgery. That's kind of like pivoting, right? Defus says, you could have trouble if you are trying to access internal services of the jump host. It's possible, but I think it doesn't work without a route. Well, I mean, this could be my new favorite tool for pivoting if it really is this easy. Yeah, I don't want to. SSRF, well, it's a heck of a vulnerability. Alright, let's do our real directory busting now. So let's bust out... Actually, let's do some GoBuster. Let's bust out the user share wordless. Dirbuster. Directory list 2.3. Medium.txt. We need to bust out all of our good extensions. So HTML, PHP, TXT, zip. Okay, let's see what works. Diva says, I only use the web UI of Legolo these days. I have to remember less commands. Oh no, that's not the right that's not the right IP address. Silly me. Silly me. Okay, so it's 1010 2020 23. .php.html, index.html, secret.php? You don't say secret.php. Okay, let's check it out. Hola Mario. I think Pinguino de Mario made this box. Yeah, we could probably look this up real quick. So a little pivoting. Yeah, it was made by Pinguino de Mario. SankLogic says, good night guys, been fun. 4 a.m. my end, night you all. SankLogic, you must be in Europe. But let's give you a Hack the Planet to end your night. And hope to see you next time, SankLogic. We'll be streaming back on
Hack the planet! Hack the planet! Shut up and get in.
We'll be back on Monday. So hope to see you then. Okay, so let's go back. So we got secret.php. What's going on here? Esta web no se puede hackear. This website is not possible to be hacked. No se puede hackear. Column Master says you really like Hack the Planet. Well, I mean, you know, that's kind of our motto over here. Okay, so hola Mario. So, I mean, this tells us that there's a Mario user, right? We could also do... We could probably do some brute force. So SSH brute force on Mario. It's a bit lame, but we can try it. Hold on. Connection is refused. It's weird. We got our connection established here. Diva says, trying to access a host which is on the same subnet as the jump host is also kind of a special case for Legolo. You can't route the whole subnet, but only specific hosts that you want to reach. I'll keep that in mind. We know that there's no such thing as the perfect tool, the tool that works for everything, so we have to keep the limitations of our tools in mind. Okay, so we got Mario. Do we just brute force Mario? With, like, Hydra? Well, I mean, we've got this brute force attack going on right now. The other thing that we could do is we could... Luigi is probably the root user. Probably. So secret.php is a PHP page, of course, and PHP pages, we can scan those for We can scan those for local file inclusion. And, I mean, it would be kind of lame to have local file inclusion on 2 of these boxes. Let's limit this to 4. Okay, so we'll keep that running in the background. Yeah, okay. Grandplay says, I'm tired of the CTFs where every web app is built with the vanilla PHP. Well, I mean, they are looking for people who could write CTF boxes. If you wanted to change that, what can we do here? So this is the secret page right here. We can do some FFUF fuzzing. Oh, I don't think we need to look for anything else on the server. Oh, that's a lot of stuff. Depends on what you're trying to teach. I mean, the goals of the box are explicitly about pivoting. Secret PHP. The secret PHP. Well, I mean, I guess. Okay, we're doing FFUF. No. Hold on. So the command is, let's do TLDR for FFUF. So path to word list example host post data proxy requests through burp proxy or man in the middle proxy. Okay. There are web app based challenges that will have a bunch of different stacks that are more varied. So FFUF or path to word lists. So the URL is going to be fuzz equals local file inclusion. Actually, I think we need to do single quotes here. And the word list, I'm pretty sure we can use the burp parameters list. Yeah, this one right here. So burp parameter names.txt. It looks like it doesn't it doesn't like brute force attacking through the through Ligolo. This is going really slow. We got a bunch of errors as well. Let me see if I can find something in my notes. So let's see, burp parameter names. Burp parameter names. Okay, I've got something from my notes. Okay, so thank you very much, Defus, for redeeming all the things. Redeeming all the things, drink all the booze and hack all the things. Let's see. I wonder what the issue is here. I guess, yeah, FFUF goes too fast. That might be the issue. Can we slow it down? Threads 40. FFUF, let's slow down the threads. Can you still reach the site? Okay, so let's try reloading the site to see if it works still. Oh, I think... Yeah, I think we can't... Oh, no, this works. How about secret.php? Check the pivot. Well, I mean, okay, so where's the pivot? Here it is. Connection established, sure. And then connection refused, connection refused. Killed it like a hacker, yeah. I think we need to slow it down. Secret.php. I mean, we can't access the secret.php endpoint. Hold on. Let me check. Yeah, it doesn't want to go. Use burp intruder. So if we just... We can't even curl the... Yeah, I think it might have crashed. I think it might have crashed. Leo Pizzas, hello. I DOSed the service. Okay. Okay, we've got curl, right? So we could try to figure out if we can access it from the jump box. So curl 2020-23. Maybe we could, yeah. It could be that only the pivot crashed. Let's see if we can curl this. We can curl it. I think it was just the pivot that crashed, because we can definitely use this. Okay, let's restart the pivot. Leo Pizzas, hello. Nice to see you here. We're doing some pivoting labs. So we've got a machine called Big Pivot. No, it's called Little Pivot, I think. And it's over at Dockerlabs. What am I using for the proxy? We're using Ligolo. This is the first time I've used Ligolo in my life, and it's actually not too bad. Okay, let's go ahead and do an ad, because we're running some... Hacka doesn't like Ligolo, apparently. Okay, so enjoy the birds. We will be back in about 30 seconds. Just have to have a little bit of water. Okay, so FurnaceX says, it's weird, I keep using Docker exec IT container, bin bash, and then compromising all these so-called locker... Yep, where is the challenge? Where is the challenge if you're able to, you know, directly log in with your bash shell? That's a master hacker right there, yeah, of course. Okay, let's go back. So let's set up the pivot one more time. Okay, establish the connection. I can't remember a box where I didn't have any trouble with pivoting, no matter which tool I used. I mean, agent dropped, agent joined, recovered an agent, starting tunnel, unable to start tunnel. Unable to start tunnel, huh? Does that mean I can't access anything? Yeah. Oh, you don't have a connection anymore. Okay, so unable to start tunnel recovery for agent file exists. So how do we I mean, I guess I could just do the thing again. File exists. Okay, so how do we delete the tunnel? Okay, so help tunnel lists, tunnel underscore lists, and how do we destroy it? Kill the current agent. Tunnel stop. Tunnel stop. And I guess we need the interface. Oh, is it tunnel underscore stop? Yeah, it's tunnel underscore stop. Invalid usage of the command. Tunnel stop. Help tunnel stop. Okay, so looks like I need to do this all over again. That's okay. Start it up. Where are we? Okay, and then we establish the agent. And then we auto route. Create a new interface. File exists. Huh. Okay, so tunnel list. So how do you use tunnel stop? Just stop? Stop a listener. Listener stop. Okay, I mean, it says that this thing is online, but we don't have an interface. Oh, this is just an agent. So active sessions and tunnels. So, I mean, is this a tunnel already, or is it just a session? Because there's no interface name here. Okay, and then set up everything for you. Interfaces, routes, and tunnels. Use a new interface. Start the tunnel. Unable to start tunnel. File exists. So this, I mean, this should be Legolo version. Let's see. Legolo NG version. Nope. Yeah, I'm not too sure which version is running right now. Okay, where are we? Okay, okay. So this is Legolo NG. The latest version is 8.2. And I'm not exactly sure which version we're using right now. Okay, so unable to start tunnel file exists. So this is the first time I really dealt with Legolo, so I might go and Google something. Legolo issues, the only one, this was the only reason I mentioned. Let me take a look. After the agent unexpectedly disconnected, a zombie tunnel that cannot be deleted occupies the TUN adapter. I mean, how would we usually delete it? Tunnel stop, no tunnel started. Okay, I mean, it looks like tunnel stop you just need to type tunnel stop. No tunnel started, right. Okay, and tunnel lists. Tunnel stop agent 2, no tunnel started. Do they include... Cobblemaster says, I downloaded Kali and the bash shell I see. Why is yours not see-through? So I adjusted the settings so that it's not see-through because it makes it a lot harder. It makes it a lot better for screenshots. So that's the reason why yours is see-through and mine is not. Okay, so what are we doing here? So Agent 2. So, I mean, Agent 1, right? So it would be tunnel stop. -- agent. No tunnel started. Okay. I mean, how do we move around this? Okay, let me change up my music and then we'll we'll try to figure out what the heck is going on. Oh, I think it's time for some Mass Effect. Okay, so, check your Legolo interface name with IPA, and then proxy try if del name interface name. So, this one, I think this is, oh, we've got a bunch of these different ones here. Yeah. Can we delete these? So ifdel. Yeah, we got a lot of them. Okay, let's get rid of these. If del is not a command, huh? It failed at some point. So how do we delete these interfaces? In the proxy? Okay, well, whoops. Sudo IP sudo IP link delete something something. If del is deprecated. What are the differences between remote port forwarding and local port forwarding? I used to know the difference between remote port forwarding and local port forwarding, but I kind of forget right now because I haven't been thinking about it in a long time. Remote port forwarding is, one of them is connecting every port through one remote port, and the other one is just connecting one local port to another remote port. I don't really remember the exact details. Okay, so we're back over here. So sudo IP link delete interface. So interface would be, I don't know, like this. And then we would repeat this for all of the other interfaces. Why use Legolo at all? SSH exists. Well, I mean, I wanted to give Legolo a try because a lot of people really like Legolo NG, and I wanted to see what the fuss was all about. Okay, we got more of this stuff. I think this is the last one we need to delete. It's just hype. Well, I mean, even if it's just hype, I want to try it out myself to see if it's actually good or if it's something that's not great. I assume the reason is the chaining aspect, which isn't really a thing in SSH. I hear that a lot of people have problems running certain tools through SSH tunnels. Like most famously, people have hard time like running like Nmap through proxy chains and stuff like that. Hacka says, let's see, it says all types of proxies that you'll ever need. And Coding for Beginners, hello, nice to see you here. Okay, we're just doing some, we're trying to do some network pivoting right now. It's magic, or we would like to think it's magic. Okay, let's try this thing one more time. Start the tunnel? Yeah. Okay, now it works, because we deleted all the other stuff. Nmap will tell you all the open ports with the normal scanning mode on SOCKS 4. SOCKS 4. Okay, so now that we've set up our pivot here, let's see if we can ping. Okay, we can ping the target now. I was gonna try to see if we could get some brute forcing done with FFUF. And I think I'm gonna go extra slow because I'm afraid of breaking the connection. Whoa. Well, I mean, it worked. We just need to make sure that Okay, filter on size. All right, so I don't know. We've got this weird web page over here called secret.php. Hola Mario, esta web no se puede hackear. T is for threads and P is per second. So, I mean, I guess, I mean, the only other thing that we could do is we could try that brute force attack again. So where was I doing? We could do another Hydra attack. And we're going to make it nice and slow because I don't know how... I don't know how fragile the pivot is. Surfer says, yo, hello Surfer, nice to see you here. And in Hydra, P is for seconds. Not for in Hydra. We were talking about FFUF. Furnacex says, I've slowly been updating my VM to join in on the box. Doesn't help that I used my... I haven't used my fun VM in months. Okay, okay. Oh, we did it! We did it! We, Alright, so we can probably log... Mario Chocolate. Okay, great. So this is the second pivot. So we can just, we can probably access the second pivot. Yeah, the third pivot's going to be tough. But I think we can SSH as Mario to that box from here. Oops, need another 20. Is this some sort of challenge on your own virtual app? Yeah, this is a Docker container challenge. It's basically it's a challenge where you need to deploy the Docker containers, and then you hack against the Docker containers to try to get the highest level of access. So this is the website we're using right here. It's called dockerlabs.es, and this is a really fun challenge because it lets you do some pivoting, which is not really something you see much, especially for free challenges. A lot of paid services let you get access to pivoting challenges, but it's not usually the case with free ones. Same password as yesterday's box, if I remember correctly. Yeah, chocolate seems to be a pretty popular one. I think it's because the same guy makes all of the boxes. But yeah, so we're now logged in as Mario. And I might as well call up Scary Hacker Voice Man to talk about this.
Hey there, everybody, it's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes out every time we compromise a box, or a server rather, and we just compromised this one. Well, Mr. I guess this is still considered little pivoting, huh? The Mr. Little Pivoting Administrator again. It seems like you like leaving secret web pages on your website that reference your username, huh? That was a big mistake. We took this username and then we did brute forcing for SSH, and then we found the password. Maybe you knew about this security issue, or maybe decided to accept the risk. Well, you accepted the risk. And now we're in again. Cause we got in previously. Anyways, you got hacked.
Okay, so we're in again. I guess we'll repeat the same things that we did before. Could you please show us if there's more inside of secret.php? I don't think there is, but we can take a look. Yeah, okay. Anyway, you got hacked. Yeah, there's nothing in here. There wasn't, well, that's okay, it's okay. This is supposed to be about learning how to pivot and stuff, right? So there's one more box that we need to compromise to finish the pivoting challenge. And I guess we can do the same trick that Defus taught us before. Let me get that one. Okay, so this is the command. And it shows us the route. So we've got ETH1, and we got 30-30-30 network. Surfer asks, pivoting means basically going from one network into another network into another network. Or rather, one network range into another network range into another network range. So it's basically moving around different networks. Okay, so do we have to upload our agent to this box as well? Well, we might be able to. Okay, so if we've got our other, well, I guess we could log in with the Manchi user, again from another box. Let me do that. Okay, so what do we do from here? Let's go ahead and okay, we got index.html, we got shop here. I don't know if I've got permissions to write to here. I don't have permissions to write to here. Let's move into the temp directory. We've got our agent here anyways. So we can Python 3 HTTP module, HTTP server, and we'll serve this on port 443 just for fun. Okay, and then we'll upload it to the target over on this, where is it? Here. Let's move into the temp directory to do this, and we will, okay, we got wget here. $2022 on port 443. Okay, so we downloaded the agent again. I wonder where you learned this stuff from. It's you learned it from all over the place, and you learn it by doing a lot of a lot of exercises. You do a lot of exercises. Eventually, you develop a you get a collection of different tricks and tools. But Surfer, you could do this yourself if you wanted to. You just need to get started. Okay, so we got our agent here. Let's make it executable. And what was that command? This one. Step 1 is Google. Man, this isn't... I don't know if this is going to work. Because I'm pretty sure that I can't contact this IP address. Well, wait. I mean, can I? Yeah, no. Network is unreachable. So, can we do it through... I don't think we can do it through... This is where it gets a little bit tricky because we're doing two pivots. And I don't think I've done 2 pivots before. I've done one pivot is pretty standard, but 2 pivots is a little bit tougher. Yeah, it doesn't work. Am I still struggling with this? No. We've gotten to the 3rd box. So I came back with some friends. Franuis? I'm not too sure. Is that supposed to be friends or something else? Okay, we got... Google it. Franuis. Do I want to Google it? Is it something I can Google on stream? Oh, okay. These are chocolates. Or are they chocolates? Oh, there's fruit dipped in chocolate. Okay, great. No? I thought it was supposed to be fruit dipped in chocolate. Okay, so what can we do with this? Raspberry. Oh, raspberries. Okay. Surfer asks, what are your views on THM and HTB? So try HackMe and HackTheBox. They're both good platforms. Of course, if you're more of a beginner, try HackMe is going to be much more useful than HackTheBox. But there's a bunch of good beginner stuff on HackTheBox as well. It's just a bit harder to find, or a little bit harder to use. Okay, so so Gruntplay, how do you use Legolo to do more than one pivot? So this is the second chain in the pivot. Discord. No, we don't have Discord yet. We're probably going to set up a Discord in about a month or so. But you need to add a listener. Okay, so I mean, I uploaded my agent to the box. I'd rather tell you on Discord. Yeah. Okay. Are you talking about the friendly? Okay, great. We got ads running on Twitch, so do them on YouTube, and we'll put on the birds again. All right, this is my favorite video, the favorite bird video. All right, we'll be back in about 30 seconds? No, 50 seconds. We have to take a little water break. And I love these little guys. They're so cute. Alright, let's put the birds away. Okay, oh, Gruntplay, thank you very much for the article. Let me take a look. Gruntplay says, I did a triple pivot for some pro lab. Do you remember which platform that was on? Was that HackTheBox or... Was that HackTheBox or some other one? Oh, HackTheBox Pro Labs, yeah. Okay, let's take a look at the... Okay, pivoting and tunneling rabbit hole in cybersecurity, and during that time I learned how to pivot using many tools and techniques. Chisel, the Forbidden Platform, SSH, etc. I found most of Depending on proxy chains, it was very slow. They're raspberries, huh? Okay, so I did, let's see. Alright, so tool setup. Okay, so we get Ligolo, great. First, set the proxy in the attacker machine. Then I send the agent into the target machine by, okay, so we upload the target. Okay. Yeah. Session start, double pivot. Assuming that we're inside and we did conduct a successful internal test. Connection to the DC, sure. Oh, okay, okay. So in this case, they're using... I prefer this savory foods, but the fruits are delicious. You have to try them. Let me take a look. This is some sort of raspberry dessert. Oh, okay, okay. So it's raspberry covered. It's chocolate covered raspberries. Yeah, it looks pretty good. Okay, so transfer it over there. Back to the Ligolo console. Okay. Type start. Oh, you're from okay, Argentinian. Okay, that's great. Set up your new network interface and you're good to go. Well, I mean, if you could walk me through it, maybe you know we could get this going. But we know what the machine is. We know the IP address of the machine. Okay, so let's see. Sample double on Ligolo docs. Sure, let's take a look. Add listeners. Okay, let's take a look at... Sometimes it's necessary to install a tunnel within a pivot. This is the case when you want to bounce on a restricted network from a machine that doesn't have access to the internet or to the Ligolo daemon. That machine can contact a host you've already compromised. Thanks to the Ligolo NG's listeners feature, you can listen to a port on the Ligolo agent and then retransmit connections to the proxy. This tutorial explains how to establish a connection through a pivot. Okay, so on the server, this. Connect agent 1 to the server. Creator listener using the listener add command. Okay, there are two mandatory parameters. OP Hacker has just subscribed. Thank you very much for the subscription on YouTube, OP Hacker. Let's give you a Nyan Cat. Okay, so listener add. So we need to specify which IP port should be listening on the agent. Okay, so we just, do we add the listener on from the console? Listener add something something. Specify a session. So I mean, this is the session we got over here. That's in English, when you throw a very flat rock in the water, that's called skipping. Pivoting, double pivoting is basically like that. It's called rock skipping in English. Okay, so address all interfaces on 4444 to localhost. I mean, I don't know. Is this what we want to do? Listener 0 created on remote agent. So there's a listener here now on the remote agent. Sure. And then any connections on this IP port will be relayed to the TCP connection here. Okay, you can confirm that the listener is running on agent 1 by doing the listener list. Listener list. Okay. Okay, so on agent 2, after running the listener add command on the first agent, you can execute the Ligolo agent on the second server, which doesn't have internet access. So instead of specifying the IP port of the daemon, you have to specify the IP of the first agent and the listening port. So it should be this. Okay, let's go back. This is the I mean, I hope it works. We just need to specify it should be, I think this is the IP address. Wait. Oh. Yeah, it's just called agent. Didn't work. Session 1 IP. So, I mean, session 1 IP, it should be this. Hold on. Oh, we need to do the ignore cert? Okay. Well, I mean, I think it's working now. What do we see here? So agent joined. So, I mean, if this works, then we should have access to the 30 network. So the 30 network, where is it? Yeah, so it should be the 30 network here. Auto route with a new interface. So we need to do the auto route again. Auto route new interface. So the new interface is for each pivot you need a new interface. Use the first one. Select the session first, select the session. So let's see. Hold on. How do we exit out of this? Control C to go back. Okay. So we want to do session 2 in this case. Okay, and then auto route. Create a new interface. Start the tunnel. Okay, so if this is the case, then we should be able to access the 30 network. Phew, haven't done this stuff. Haven't really used Legolo NG before. But you know what? Let's give it a try. So we should be able to ping 30, 30, 33. Yeah, okay, we can contact it. That's good. Now we need to do our... What is it? Okay, we can try SSHing into the box. Mario at 10, 20, 20, 23. Okay, so, I want to do my quick ping sweep, and let me do the ping sweep from this box. So in this case, we're doing the 30 range. 30, 30, 30. There's no ping. There's no ping. Use a shell script, that one. Yeah, there's no... Use your Kali machine. Yeah, we could. Okay, so there's the 2 machine and the 3 machine. I'm pretty sure the 2 machine is the local host over here. And so big shoutouts to Gruntplay and Defus for providing all these great commands from their notes. Yeah, it's probably oh, we could use ifconfig. Or IPA. Well, I mean, this doesn't tell us our IP address, unfortunately. Actually, wait, we might be able to do it from here as well. But there's probably there's no IP command on here. That's okay. Oh, you can do it from Legolo? I had no idea. Yeah, okay. This is cool. It'll tell you, yeah, this is awesome. Okay, so our machine is the 2 machine, so the 3 machine is the one that we need to compromise. So we would do an nmap command to scan the 3 machine. So 30, 30, 33. There's only port 80. There's a cool C2 that called Havoc that implements Legolo as well. I mean, it certainly does. When it works, it seems really cool. But some people are skeptical. I think this is. I mean, I think it's pretty cool, but we need to. Okay, we can access. Upload your upload your file. It says. Okay, well let's go ahead and access the server. So it's 30, 30, 30. And it looks like we've got some malicious file upload. Yeah, it looks like malicious file upload for the last thing. It's a big mess. When a wire cuts out, you have to reset up everything. I think, well, I mean, that's going to be the same for any other software, really. Okay, so can we just upload a PHP file and call it a day? Because that would be nice. And the other thing we should do is we should probably do some from web app enumeration. So where's our derb? Okay, there's an uploads directory. Just upload a Pawnee shell. Yeah, I was thinking of doing that right now. Okay, so what will we do here? I think I've got a... Let me create a web shell. So nano web shell.php. Where are we? Too many windows open. Rev shells. I'm just gonna get... no. I'm just gonna use a simple one. Nice and easy. Okay, so PHP command, small. Am I solving the machine? But it is PHP. Yeah. I mean, I'm pretty sure this is PHP. Oh, it says index.html. Well, I mean, I'll figure that out afterwards. Let's try uploading this PHP web shell first. Okay, where were we? Here. Here. Upload from the temp directory webshell.php. It's been uploaded. So it says it's been uploaded. It's probably in this directory here. And let's see if it works. It works. We've got, you know, all of the vulnerable methods for these machines have been very, very simple, but the challenge wasn't using the challenge wasn't abusing the web application. The challenge was pivoting. So I guess this is really cool. Yeah, it's a lab for learning pivoting, so this is fine. Let's... Where would we... How big is this chain? Seems pretty lightweight, boilerplate. Set up to train some pivoting stuff. Literally stone skipping. Well, I mean, this is the 3 chain. So our local host is 0. Then this is the 3rd machine in the chain. Oh, okay. How large is it in gigabytes? It's not a very big file. I think it was like 500 megabytes. Let me check. Little pivoting, yeah, it's like 400 and it's under 500 megabytes. Not gigabytes. These are all Docker containers. They're all pretty small. Yeah, 409 megabytes. Okay, so I should be able to finish this off by setting up a reverse shell. Bruno6 says cracked it. Well, I mean, I'm pretty sure Nagolo was neat. Well, I think Hacka is not a fan of Lagolo. But I mean, it works okay. I think it's pretty cool that you can set up like this kind of bash c dev CCP. I mean, what do we do? Okay, so we got our reverse shell listener, shell TCP connection. Accept fingerprint is nicer than ignore cert. Accept fingerprint. This is all foreign stuff to me, but who can we... I'm pretty sure we can't... Hold on. Okay, so... Which box is this again? there's no ping command. There's no ping command. But there's another way we can figure out if we can access this box here. Okay, so we got test.txt, Python. Okay. What's up with the epic music? This is Mass Effect music. And that's the size if you want to try out some pivoting and you can spin it up quickly. What was the name of this? I'll save it. So this is called Little Pivoting from Dockerlabs. So I'll just... And there's another one called the Big Pivoting, which, well, we'll try. We might try this out later. If Little Pivoting seems to be working just fine. That's nice. Grand Play says, by the way, I came to the stream because the title says Learning Bin Hacking. Oh, binary hacking. Yeah, we were doing binary hacking earlier today. We did. We were learning some buffer overflow stuff. It looks unnecessary. Unnecessary? Which part do you think is unnecessary? For big pivoting? Big pivoting. Well, I mean, you could. I mean, why not? Why not? Why not if you can? Okay, so we need to figure out if we can contact this website or not from these other servers. Where are we? Here? Which curl? Which wget? Okay. Big pivoting, like a realistic scenario. Well, I mean, I'm not sure if it's super realistic or not, but it is a good exercise. Sorry na, greetings from PH. Do you mean the Philippines? If so, hello and greetings. I'm from Canada, and there are a lot of Filipinos in my city, so welcome. Okay, so what are we doing here? So wget. And let's see if we can contact 10.10.10.1 test.txt. Network is unreachable. Okay, so we can't. So the connections only go one way. So, I mean, how do we get a reverse shell then? Because this is the last thing we gotta do. We have to get a reverse shell from the machine that's three layers in. Add a listener for the rev shell. Oh, really? Back to adding listeners. Okay. So, Connection is refused? That's funny. Okay, listener. Listener list. So do we need to add an agent? Furnace Lagolo is a little annoying to clean up, though. I can believe it. Okay, so we got our agent over here. And I guess we would do Python 3 HTTP server on port 443. And then we would upload it to the target. Listener add 1234 1234. Okay, so we've got our web shell over here. So we can do Yeah. Alright. Let's figure out what tools are on here first. There's no ping. Of course there isn't a ping. Which wget? There is wget. So wget 30, 30, 32. And port 443. Agent. Okay, let's see if that went through. Now, if you're just going to send a shell, just do something like netcat. Oh, really? Oh, that was... Yeah. And I mean, in that case, we need to do a bind... That's a bind shell, right? Did we upload the agent? Yeah, we uploaded the agent. Okay. So if we uploaded the agent, we can make it executable. We probably need to URL encode this thing. So it's %2b. Like, it's not 100% necessarily to use the agent, just add listener to session number 2. Yeah? Hold on. Let me see if I can set up a bind shell. So, I mean, setting up bind shells usually isn't the way to do things, but you know what? We'll give it a try. Vetarian. Let's give you a fun video redeem. How about a Hack the Planet?
Hack the planet! Hack the planet!
Just add a listener to session number 2, like the same way you downloaded the file. Oh, okay. Let's, where are we doing it? Here. Show listener list. Okay, so we're doing the Mario agent over here. Netter says, I love it when I work in some night and find something live like this. Yeah, Netor, hello, nice to see you here. That movie, Angelina Jolie peak. Oh, are you talking about hackers? Yeah. I mean, everybody was a lot younger back then. Okay, so listener add netcat whatever, and then listener add something. You do a normal bash rev shell. Okay, I'll give it a try. Hello sir, do you think bug bounty is still worth it in 2025? If you wanted... I would recommend getting a job as a regular web app security tester. Regular web app security testing is probably way more... It's probably more stable. More stable than doing bug bounty, because if you're just starting off doing bug bounty, it could take a really long time before you start making money. But people who are already in bug bounty, yeah, Cybernerd Dante, I see you there. Okay, so what is it? Listener add address 303032, and we can connect this to localhost 11601. That's the default one, right? I mean, does it matter what we do for the remote host? I guess the remote host just has to be a port that's not being used. What is this C2? It's not a C2, but we are using the Legolo NG. The Legolo NG, what is it called? What could we call this? I guess we could call it like a port forwarding platform or something. Anyways, listener 0 created on a remote agent. Okay, so listener 0. Then we need to, what was it? Use listener. Listener add session. So here's the session here. It's the Mario user. And in to win. Hello, nice to see you here on YouTube. Let's give you a, yeah, it's tunneling stuff. Let's give you a, man, I'm gonna forget all of this as soon as the night is over. Let's give you a Nyancat. Welcome to the stream. Okay, so netcat something something. Oh, okay. Oh, okay, I see. All right. So, let's see. Where's my reverse shell? My reverse shell's here. It's on port 443. So I need to connect to port 443. So listener add. So I'll just add one to port 443. Address already in use. Okay. Wait. Oh, no. Yeah. Okay. All right. So let's... Okay, so the listener's up now. And does that mean that we can communicate? Pop a shell. Well, I mean, are we ready to pop a shell? I just need to figure out what command we're going to be using for this. I guess I could upload a binary with using the Venom. Just use TCP. Well, I mean, dev TCP? I mean, is it... Well, I'll give it a try. Just cause you provided the command in the chat. You know, because I love copy pasting commands. Okay. Tashin, hello, nice to see you here. Redeem Nancat. Do you need Nancat? Wait. Oh, it doesn't... I don't think it works for YouTube right now. But let me get your Nancat for you, Tashin. Oh, wait. The Nancat might be... Yeah, the Nancat is on cooldown right now. Why don't you have a Desert Frog instead? Okay, so, I mean, let's see if this works, because it's kind of... Because there's a lot of special characters in here, and they might get blocked. I don't think that worked. Okay, so what we could do is we could try URL encoding this. Larvine, by the way, hello, nice to see you here. And thank you very much for following on Twitch, Hymn of Words, thank you very much. It shouldn't be necessary. Do base64 encode. I don't, maybe we don't need to base64 encode, but let me do some URL encoding. Bin bash or bin.sh. Let's encode all this stuff. Okay, so the other thing we need to make sure of is that everything is... Wait, should we be using this IP address, or should we be using the IP address of the other machine? Because I'm not completely sure. Okay, let's try the 30.1. Oh, okay. So if it's the 30.1, okay, didn't go through. With the Python interpreter. Python interpreter? Larvine, by the way, says, I'll watch later if I have time. Overall, cool channel. Thank you very much, Larvine, by the way. Okay, so the listener is listening on port 4444. Okay. So the other problem is that it's yeah, it's port 4444. Sure. Let's provide port 4444 in this case. Where is it? Oh, it looks like we've got a connection. Where is it? Yay! Okay. Wow. We just did pivoting through 3 chains. That was something else. Okay, let's call in. It was unnecessary to use the other agent. Okay, so let's call in Scary Hacker Voice Man one more time, and we'll talk about how we... Where's the victim machine? So I'll talk about it in just a second. We gotta call in Mr. Scary Hacker Voice Man.
Hey there, everybody. It's me, Scary Hacker Voice Man. I'm back again. This is the 3rd time. I can't believe you woke me up for this. But anyways, we managed to find another web app vulnerability. This time we pivoted through 2 machines, and we found malicious file upload on the 3rd machine. Maybe you knew, well, you probably knew that this was vulnerable. It's okay. But we hacked you. Ha 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 ha. And now we're in.
Oh, this is cringe. Yeah, well, I mean, you know, you gotta embrace the cringe every once in a while. So where's the victim machine? So the victim machine is this one right here. Let me get you Dockerlabs. So this is Dockerlabs. This is the little pivoting machine. We're using Kali Linux. Yeah, we're using Kali Linux. CyberNoip says, I need to be as dedicated as you. I need to spend at least 8 hours a day on Kali Linux. That's not necessary. You don't need to spend 8 hours a day on Kali Linux. Okay, so let's go back. Let's see if we can get root on the system. Okay, easy provask. Easy provask with the env variable. We can just look this up on GTFO bins. We got sudo, we run this, and then we become root. Okay, we're root now. Great. It's the pizza guy, Kelly Linnox. Lynn Cox. The louder you are, the less you hear. Yeah, for sure. Okay, we rooted the system. Yay! Great. So there is the web application is as expected. Great. All right, everybody. I gotta get off because it is way past my dinner time and I need to eat. But let's see if there's some other cool people that we can pass everybody off to over on Twitch. So everybody, the other thing that I want everybody to know is that we have a Reddit. Oh, okay. By the way, Big Pivot uses some of the same image names. I think they just add a few more machines, that's my guess. Happy 4th to all you nerds. Cybernerd Dante, hey, thank you very much for coming by. If you don't clean it up properly, it'll pull over containers from Small Pivot. I'm really sorry to hear that, Furnosec. Okay, so we every week we stream on Mondays, Wednesdays, and Fridays, and the next stream is going to be on Monday. And we'll probably update the stream schedule over the weekend, but I hope everybody has a great weekend. And let's see who's streaming right now. Ah, that's a great thumbnail right there. That's a great thumbnail right there. Let's see. I think we can raid into the science stream. Actually, RWX Rob gave us a raid the other day, so we're gonna raid them back. So they're probably doing some sort of Linux stuff, because RWX Rob is all about the Linux stuff. Oh. Well, I mean, Gruntplay, do you have a suggestion? If you got a suggestion for a raid, let us know. Refresh the Reddit. But yeah, we'll give RWX Rob. I don't this time. No worries. Okay. Well, I mean, Rob also has kind of connection issues right now, so I'm not too sure. Let me take a look at my own Twitch and see if I can locate somebody to raid. Yeah, let's raid into this. Let's raid into the science stream. Okay, science streams. They're usually doing lots of science-related stuff. Quantum Apprentice. Okay, yeah, we can raid into Quantum Apprentice. Okay, let me get Quantum Apprentice's channel. Oh, yo, Dio. Hello, nice to see you here. I'm new to Linux. Yeah, I mean, what do you want to learn? We're just about to end our stream, but what do you want to learn? Yeah, the ads. All right, we're setting up the raid for Quantum Apprentice. Everybody, thank you very much for coming by, and thank you very much to our good friends Deefus and Gruntplay and Furnosec, Cybernerd Dante, all the rest of the people. If I missed any of you, then I'm sorry, but have a great weekend, and we will see you next time. Yeah. Just send me a message on Twitch, and we can talk. All right, later, everybody. Happy 4th of July. And we'll see you next time. Okay, so just for us YouTube people, we're just going to set up a cool thumbnail so that we can have a really good thumbnail on YouTube. Just a second. How about this one right here? That looks pretty cool. Okay. All right, everybody. Let's, we're going now. See you next time, and have a great weekend, everybody.